Good morning, everyone, and welcome to the Southwest Center for Occupational Environmental Health Industrial Hygiene Seminar Series, brought to you by our continuing education program here at the Southwest Center at UT Health School of Public Health. My name is Michelle McDaniel, and I am the Director of Outreach and Continuing Education, and I am glad you're joining us this morning. We have a great event from about 8:30 to 3 with some breaks and lunch. And a lot of content to go over for some lead updates. So just a little bit about our center. We have academic training programs, an outreach and CE program, research and practice, and then we do have a large conference coming up that we're pretty excited about. So you'll be hearing more about that through email in the next coming week. Just for best practices for a successful session here, if you're experiencing any connection issues, make sure you're not connected to a VPN. You can always change your audio if needed by using the change audio button on the bottom of your panel with the 3 dots. Attendees are muted for this session, so you're going to communicate with us through the chat and Q&A box. And video cameras are only being used by panelists today. And panelists, if you're not speaking, please turn your camera off to reserve bandwidth. And then for everyone, if you experience just continuous issues, sometimes if you close other applications, that seems to help. And we are recording this session, and it will be shared via email probably tomorrow, and then we will also put it up on our website. And so this is just for our panelists. You should have your menu in the bottom panel if you're using just the regular browser version of WebEx. If you're using the application, I think it's on the top. All right, so I'm going to quickly go over the agenda. Again, my name is Michelle. I'm going to be one of your moderators. And joining me in moderating is Mr. Bill Young, who is a senior EHS consultant and longtime stakeholder of our AIHA seminars, formerly known as the Greater Houston Industrial Hygiene Council. So I did some rebranding, as you've seen, but it's still the same setup. Next we have, well, first up we have Jan Koehn with, she is the president of JK Inc., and she's going to be discussing the Summary of Lead Surveys project with exposure assessment and results. And then we have Dr. Chip Carson with Environmental Medicine Consultants in Cincinnati, and formerly with us here at the Southwest Center at UT Health School of Public Health. And he's going to be discussing lead exposure and human health through the ages. We're going to have a break, and then we're going to bring on Brian Stott, president of Risk to Reward Consulting. And he's going to be discussing industrial operations involving lead exposure. And then we're going to give a short lunch break, about 30 minutes. You can stay on, you know, we'll take a break, but you can stay connected if you want, or just pop back in at 12:10. And we're going to move on to Mr. Freddie Polanco, president of Professional Environmental Training. And he's going to be discussing regulations and resources to lessen lead and risk in the environment. And then we're going to have Mr. Bernard Fontaine, managing partner of the Windsor Consulting Group, for occupational health hazard of leaded gasoline used in the transportation industry. And then another break, and then Mr. Bill Young, joined by, I think, a few others, are going to be talking about testing for lead paint and other land contamination transmitters. And then in the afternoon, I'll wrap it up. I'll get some information, just a short poll from you in the audience. And then we'll close out the day. We will be offering continuing education units, and those will be sent out to you tomorrow, along with an evaluation. Okay, so let me stop sharing my screen. And we are going to go ahead and pass this to Ms. Jan. Sylvia, if you will pass the ball to her, then she can share her presentation and get started. All right, Jan, it's all you.
Really? You sure you don't want to take a shot at it?
I'm sure. Thank you. Go ahead.
All right, I want to give a big attaboy to Bill Young. When Michelle hits me up about doing stuff, we wanted to do this as a CE event through the Gulf Coast IH section. So of course, Bill is my go-to kind of guy for CE events. I said, Bill, let's do an event. So he came up with lead, and next thing I know, he's finding all the speakers and pulling everything together. So he did the majority of work. I only stepped in and said, okay, sure, I can find some data on lead surveys and some other monitoring things that we've done. So I'm taking the first slot, doing some consulting challenges that we dealt with hazardous materials and lead. Okay, so there are hazardous materials available in different occupational workplace environments. Some of those that we've been asked to look at as a consultant, more from a survey perspective potentially, could be lead, asbestos containing materials, and a lot of times we do both of those for surveys when we walk into different type of workplaces or buildings or facilities. Potentially microbial agents, PCBs, radioactive materials, and maybe some other hazards that hadn't been thought about, but maybe it's something we're able to take a look at while we're walking around the site. So these can be identified, questions can be asked about the building or facility, past use, historical information, if there were some type of industrial processes or manufacturing type of work environment, or we see some type of equipment and things that are out there. All right. From a consultant's perspective, I mean, when we're asked to do something, we really need a scope of work in order for me to put together some type of project proposal, or to even get our arms around with what it is we're going to do. What type of equipment do we need? Do we need to take samples? If so, what type of samples? What kind of lab facility and what type of lab analysis are we going to be doing? What are the methods for that? What are the minimum detection limits and QA/QC issues? So these are some of the things that we think about. So examples of some of the survey efforts that I'm going to talk about may involve the presence of different types of hazardous materials. Could be lead, could be asbestos containing materials. Maybe we're looking specifically for lead-based paint. Maybe they're looking to do a demo project, and therefore they're going to find materials and need to figure out if they're hazardous or not, and or take samples to determine what type of waste classification or what type of disposal method of different materials is going to be necessary. Perhaps looking at contamination of different facilities based on the history of the property or previous use of hazardous materials, including lead at the site. Or maybe we're moving towards doing some type of remediation, and again, dealing with a variety of waste materials that need to be categorized and therefore disposed of properly. So again, consulting projects can focus on a variety of these hazardous materials, maybe singularly, maybe multiple. Maybe we're looking at lead particulates that are generated by processes or contamination on surfaces. Maybe we're getting ready to design some type of remediation project. And so therefore we need to know from the survey event exactly what's there, how much and where, so that we can write that into our specs regarding what type of contractor we need and how we're going to be dealing with it. From an industrial hygiene perspective, we get pretty fired up about doing exposure assessment. So maybe we can even do some airborne monitoring from a breathing zone level and look at that in compliance with OSHA regulations and standards and build that into our project. Perhaps it's specifically about lead-based paint and other types of design materials and what kind of controls were already going on in the workplace to maybe lessen some of those areas or levels of contamination that we see. And obviously, we're pretty tuned in to looking at the overall health and safety of the workplace, if it's still currently in operation or if we're moving towards demolition and disposal. So again, I stress from a consulting perspective that the project scope of work is pretty doggone important. So are we doing walkthrough surveys? What type of hazardous materials are we looking for? What type of processes or operation were previously been going on? Do we need to look at that for surface contamination, or do we also need to dial in some airborne type of monitoring? Are we looking for lead-based paint in particular? And if so, how are we going to approach that? There's several different ways. We've incorporated different combinations of these in some of the project case studies I'm going to talk about. Maybe we're using lead check swabs. Those are pretty quick and dirty with regard to yes or no. Do you have something? Do you not have something? Again, it's not a drop dead method that you're going to be wanting to talk to with lawyers in a court case, but it can give you a positive, negative, yes or no. Are we going to move forward and take some bulk samples of some of these types of suspect materials? So bulk paint chip samples, and therefore send them to a lab to do analysis and have all the QC and the minimum detection limits and the sensitivity associated with that. Or maybe we're messing around with looking at waste characterization or testing, and therefore we have to take bulk samples and maybe do TCLP testing to figure out how we're going to store, treat, and handle those materials and how they ultimately need to be properly disposed of, along with the documentation that goes with it. Perhaps we are dialed in to doing exposure assessment and therefore doing some airborne monitoring. Maybe we're going to use some NIOSH methods for that, 7300, where we can look for lead in particular, or we can look for other elements if they may be involved in this process, or maybe a 7303 is a modified method. Again, industrial hygienists are pretty fired up about using AIHA accredited labs. And if we're looking for lead and have the backup data documentation and QC that goes along with that, then we're going to use an AIHA accredited lab that is a successful participant in the Environmental Lead Laboratory Accreditation Program. Perhaps we also are going to be doing some wipe samples. So maybe we're going to be doing that within a certain template where we're going to wipe within that template and therefore get a square footage associated with that. So the results can be expressed as micrograms per square foot. If we're doing remediation, what are we going to use for our baseline, and what are we going to say is successful remediation? What's our endpoint that we're trying to get to so that we can provide that documentation for the client and therefore sample appropriately? All right, again, AIHA accredited labs, using for surveys, using for exposure assessment, airborne monitoring, because again, I want the QA/QC to back up what we're doing and verify the results that they get. So by using a third-party laboratory with the appropriate accreditations, that's pretty much going to give it to me. I also established pretty good relationships with the laboratories. They help me figure out my approach, sampling strategy, how many samples, do I need replicate samples, filling out chain of custody forms, and all the appropriate documentation that goes along with it. If we're doing air sampling, again, we're probably going to be taking, full shift, airborne breathing zone samples for dust particulates, and maybe we're looking specifically for certain elements or maybe just lead, okay? And again, maybe we're taking surface wipe samples. How are we going to do that? Are we going to use small little smear tabs? Or we're going to use ghost wipe type of materials? Found show and tell. Figure we have to fire mix something up on Thursday morning, don't we, to keep everybody awake? Are we using ghost wipes to wipe within a certain surface area so that we can get our results expressed appropriately? And then again, what are we going to do with that data when we get it? How are we going to interpret it? How are we going to write it up and document it? And how are we going to use that to determine what the level of contamination is, what else we need to build into our specs or other documentation, or does that change our airborne sampling strategy or our clearance, and how do we determine what a successful remediation is? I'm going to talk about one little project where we did do some TCLP testing. Again, environmental waste disposal is not necessarily my claim to fame, but we were asked to do it. And so we took some bulk samples, sent it to a different laboratory, again, using different methods, EPA methods, and how that data was reported. All right, some of the project case studies that I'm going to be talking about are bulk sample analysis, predominantly of lead-based paint materials. In a lot of cases, we kind of did some combination surveys looking for asbestos-containing materials as well as lead. Maybe these were associated with renovation, or maybe even moving towards facility demolition projects where we're taking it to the ground, segregating the waste materials, doing some TCLP testing, and then figuring out how those need to be properly disposed of, how that needs to be managed, and manifests that go along with that. Did quite a few industrial facility, again, both ACM and lead surveys, predominantly lead-based paint. We looked at certain buildings and or equipment investigation for lead and helped come up with some control options for the client to review and consider. We did a lot of field surveys, again, for different types of materials and buildings for lead. The waste characterization by TCLP for proper disposal. We also did some monitoring at a firing range. This included both airborne monitoring and some surface wipe samples. We moved on and did some exposure assessment related to lead remediation. There were other hazards and things involved in this, but our inclusion was to help more with the lead remediation part. So we did surveys by checks, bulk samples, and or wipe samples, and then they brought in a contractor in order to take a look at that. And we did airborne monitoring during the remediation process. They didn't really want to do personal monitoring, but we did area monitoring as they were doing disturbance of some of these different materials within the workplace. So looking at dust exposures associated with airborne issues during this remediation process in segregated type of containment areas. Plant site surveys, preparing for abatement and remediation, perhaps even demolition and or salvage. Sorry about that, I'm the only one holding down the fort. Let's assume it's, okay, let's look at one of the first lead surveys. So here we were looking at some office and warehouse facilities that were remaining for an old site. The scope of work involved looking at both asbestos-containing materials as well as lead-based paint. And so they wanted to know what was currently there because they were moving toward demolition of the site. And so we did a combination of surface wipe samples using both lead check swabs as well as bulk paint chip samples. And so we did that on some building surfaces, different support structures, some of the bollards around the site. We looked at numerous painted surfaces, and the bulk paint chip samples ranged from less than 0.005% to 0.99%. We got one of the red-based primer levels and or yellow paint with the lead-based paint that had a content that exceeded 0.5%. So here's kind of a snippet of some of the bulk paint sample results. So we took these in separate baggies, labeled them, wrote down descriptions and locations, sent them to the lab. This is a summary of the results that we got. So again, for that middle bollard, it had both underlying layers of both red and or yellow paint. We got 0.99% of lead. Examples of that. So the white paint was on the outside of the building on a vertical gutter. You can kind of see the galvanized, and you can see some of the red if you scrape down underneath it. The picture on the left, we did it with some of the lead check swabs. So as you break the swab and mix together the A and B solutions, put it on the surface, it'll start to change color. So yellow if it's negative, pink if it's positive, and the darker the pink is, supposedly the higher lead content with the lead check swabs. Okay, the bollard you can see has a lot of rust and a couple different layers of things going on there. So that's the one we got with some of the lead-based paint. Okay, another survey that we looked at, again, doing both asbestos as well as lead-based paint in a warehouse facility, kind of on the east side of town, a large facility that they were going to renovate and repurpose. We did surface samples, again, through using the swabs, as well as 3 bulk paint samples that we sent to the lab, analyzing for lead. We looked at structural columns, beams, some stairs and steps, corrugated metal walls, also in a separate little storage building. They kind of had some white paint over some clay tiles. So we took 4 of 7 swab samples that indicated maybe we had some lead-based paint in the area. We took 3 bulk chip samples, and we got 0.047% on the steps, to some white paint on the clay tile, as well as 22% for a painted column that had multiple layers on it. Here I put 3+. I do have some pictures. Here's some of the bulk paint lab results that we got back from the laboratory for our 3 different materials. So these we took and added to our table. And here's some of the pictures. So we had a lot of columns that had a lot of different colors of paint on them. And as we would scrape down under the white paint, you can see some of the red paint and the primer going on there. We also looked at some of the warehouse walls that had white paint as well as some green paint on the wall surfaces. Here's our center column. You can see the bright pink that we're getting just from wiping the lead swab on there. So that kind of tipped us off that we had something going on. So we scraped deeper down, and you see some orange, and you see some of the red primer. So pretty close to sure this is what was alarming with regard to, yes, we're seeing some lead-based paint. The other picture is kind of that white paint on the clay tile that we saw in that separate storage building. All right, I first started doing some asbestos and lead-based paint surveys for some a gas plant client, and so is going to do annual 3-year industrial hygiene monitoring surveys. They also wanted to go ahead and said, well, can you look for lead and asbestos? I said, sure, we can do that as part of our walkthrough surveys. So again, we started to employ some of these lead check swabs. And depending on the swab results, we would take some bulk paint chip samples and send them to the lab. So some of the things that we looked at were structural columns, supports, beams, a whole lot of piping. Okay, so pipelines are real into piping colors. And so they have a predominant gray or blue or whatever the case may be. So looking at those different paint layers and maybe looking a little closer for the base layers underneath. Skids, metal building services, gray paint was kind of the word of the day within this facility. So we had 4 results that were at the minimum detection limit of 0.005% that we got on piping. We looked at some vessel and some filter structures, got a little bit higher, up to 0.33% lead. On a piping or a bypass meter, again, a little higher, and the highest result that we got was 3.8% on an old compressor skid. So here was kind of a summary of some of the bulk sample results and a little bit of a description about where those kind of came from. And then I have pictures. Here's the bypass meter where we did some swabbing on that, as well as took a bulk sample. The compressor skid, again, all covered with gray paint, but usually we look for areas where there's chipping or some type of disturbance and try to swab down on those lower base levels, as well as take a bulk sample of the whole paint material. Here's the lube oil filter. A couple layers of gray is on that, but you can see down at the bottom of the vessel. Again, we see some of the orange, we see some of the red. So therefore, we pretty much think we're going to have a little bit of lead going along with it, along with an old piece from the waste boiler section. All right, let's look at lead-based paint on a domestic and fire water tank that was inside a hospital facility, and they wanted to do either demolition or renovation associated with it. So again, we did some bulk samples. We started out by jumping in with some of those lead checks just to see what we would get. And we also collected 4 bulk paint layer samples. So this gives us a range of results between 0.027 and 3.6%, with one result that exceeded DHS level. Another problem I had with doing some of these lead surveys was, what do I compare it to? I mean, there's HUD requirements, there's consumer product safety requirements, Texas has some requirements. I mean, what really applies for some of these different scopes of work or different facilities or equipment that we were dealing with? So our results for the swab samples all came back positive. Again, using the lead check swabs and just wiping it on the surface, they were turning pink to some degree. And then here is the bulk samples that were taken in the same location. So the dark green paint, the red paint that was a stripe on the side of the tank, and I do have a couple pictures after this. The maroon primer that was under the dark green paint, that's the one where we got the pretty big hit, but the brown paint on top, not necessarily. So here's our dark green paint on the north side. Here's the red stripe, okay, that didn't necessarily come back positive. Here's the maroon primer with the big red arrow. That is the one that came back positive, both for the swab as well as analysis of the bulk paint sample. And then the last one was the brown paint on the top of the tank. Okay, this client, also a TMC facility, has a surrounding black wrought iron fence around the property. And they wanted to repaint the fence. And so they wanted to take bulk samples and have those analyzed for lead. And so they decided to collect them themselves, okay, and bring them to us with some pictures, and then have us send them to a laboratory. So of course we used the AIHA accredited facility for that. And we got a range of results at the minimum detection limit, as well as a little bit higher. The highest result that we got for the bulk lead paint sample was 0.022, again, which I kind of put that up against DSHS recommendations for percent lead by weight. So here's the lab results for some of the bulk samples. Okay, pretty small levels. Here's our largest level that we saw, 0.022%. I guess that's it. Okay, this was the TCLP one. So we were doing some renovation in a hospital radiology area, and there was obviously lead lining in the walls. And so the first request came from the facility guys and said, okay, what do we do with it? And, knowing that the abatement contractor probably wanted to salvage and take it out and use it somewhere else. So obviously they have lots of different radiology areas, lots of different equipment areas. So lead lining and walls is not necessarily a big surprise, but the facilities group asked that, you know, we would do testing for the TCLP to help with, you know, what are they going to do regarding waste disposal. So we took some of the bulk material, which was pretty substantial. So there's big panels and sheets that pretty much go behind the sheetrock layers of the wall surrounding the equipment that was previously in there before they decided to do renovation and or demolition. So we took a sample of it, we sent it to the laboratory, a different laboratory for TCLP, for lead in particular, as well as some other metals. We got the results back and reported them. I'm pretty sure the contractor, as I say here at the bottom, kind of recycled that material and or salvaged it. I don't know that it necessarily went in a specific waste disposal pathway, shall we say. So here's the cut of the bulk sample TCLP results. So obviously we got a pretty high number for lead. Not necessarily picking up any type of metals that go along with that. That's referencing an EPA method that goes along with it. All right, let's look at a survey project where we did a little stuff for a firing range for a government type of agency. So they had officers coming in and doing 1 hour of qualification training, range shooting at the time. They were using a private range, and so the government wanted to see what the current conditions are, what the potential exposures for their officers were by using this range. So we did airborne monitoring results. We looked at 8-hour TWAs, even though they shot for an hour or so with a little bit of prep on the front and the back side. We also did some surface wipe samples for some of the areas within the range, both in the retail area as well as within the firing range. And then we also did some floor surfaces, and we looked at airflows a little bit quantitatively, but also with smoke tubes. I didn't include some of those pictures, but I have some of the lab results. So these were done by a government laboratory. We collected the samples, airborne samples, breathing zone personal samples, and sent them to a lab. Giving us results of those airborne wise and showing the detection limit. We took wipe samples, and again, a pretty big range of results. So not so much outside the range. We did a windowsill kind of at the back of the firing range, and obviously some of the airborne lead deposited on those surfaces as we wiped that within a template. And we obviously got a little bit higher levels on floor spaces and wall spaces physically within the firing range. Okay, so that makes sense based on what was going on. Okay, another interesting project involved, they were moving toward lead remediation. They had other types of contamination that were at this segregated and confidential site, more for radioactive materials, but they also had a machine shop and some other areas where they were making some of this equipment and instrumentation that had the possibility for lead contamination. So we did some initial swabs. We did wipes using the template within a certain square area, sent them to the lab for lead analysis. Again, we got very little to a whole lot. I've taken some cuts of some of the results. So again, with swabs, you know, positive or negative, we were trying to figure out kind of where to concentrate our efforts on different types of machines and on rubber mats that they were standing on or that they may have had on the workplace. So we did some swabs with some of that and some wipes using the template that I mentioned. Here's some of the wipe sample results in micrograms per cubic centimeter. So again, on some of the equipment, the metal shavings obviously was tipping us off that we had some lead issues going on there. Here's a picture on top of the bandsaw or some of the different type of lathes. We tried to do it consistently within that template, wiping with the ghost wipes, taking pictures of the area and doing it within that confined surface area so that it would be relatively consistent, even though you're going to get, you know, quite a range of results. So more surface types of testing in the smelter room. Obviously, we're going to see some positives going along with that, and maybe on some carts that were used to transport equipment or supplies from one area to another associated with that smelter room. Floors, I was real interested in looking at the floors because I figured people were tracking stuff from here to there, as well as for the metal cart that I mentioned. So here's the lead check swab showing the pink just as an initial screening procedure. But we also did some of those wipe samples. So same type of thing, on top of a file cabinet, on top of the grinder that was pretty closely associated with that smelter. So we did see some results for that. Okay, we also did some airborne monitoring. As I said, the initial scope was kind of to move toward remediation, but we kind of had to do the survey first to get an idea of what kind of results we had, to get our arms around, okay, what's going to be the scope for remediation? How are we going to address it? So we're also going to jump in there and do some airborne exposure assessment associated with that. So they were bringing in a third-party contractor to do that within a separate segregated area. So we ended up doing some airborne monitoring. We did it more as area samples on stands as they entered that containment area, suited out. We didn't necessarily were able to do it on the third-party contractor personnel themselves. So we got pretty low results, less than 0.003 to less than 0.004 milligrams per cubic meter for a full shift type of sample. And then we also did some initial area baseline monitoring before they started doing some of this disturbance and got up to 3 micrograms per cubic meter. All right, so here's some of those results in the machine shop when they were doing some cleaning on top of very high ductwork up by the roof before they were going to start demolishing some of those materials. That was early on. These other next two slides show that, again, you know, minimum detection limit less than 0.003 to less than 0.004 within those work areas as area samples during some of these lead remediation potential disturbance activities. All right, the last one I have is a pretty big abatement, remediation, demolition type of project. We were decommissioning a plant facility that was definitely going to be demoed, taken to the ground. So we initially did ACM as well as lead-based paint surveys. We wrote up technical specifications that were included as part of their contract documents that they put out to bid for the demolition contractors, and they obviously brought in hazardous material type of subcontractors to be able to deal with the asbestos as well as the lead-based paint. Some of them had that capability in-house, but others brought in other contractors to get price and cost estimates to be able to add that into the bids that they were submitting for the client. So pretty big manufacturing facility, had numerous types of process units and plants. The surveys were done in 2019. The specifications were pulled together. They had some other environmental consultants looking at waste, groundwater, undersurface type of stuff because there was other contamination from the previous pesticide manufacturing. But the project removal and the demolition activities were undertaken during 20 and 21. So we didn't necessarily use too many swabs with this one. We went directly just to bulk paint samples, sent them to a laboratory. so that we would have survey results that we could include as part of our technical specifications. Again, more from a HAZCOM standpoint to make sure the demolition contractor was aware of, what they were getting into and how they were going to have to treat and handle different types of these materials. So we did initial plant survey documentation. There was numerous process units. It was previously used for pesticide manufacturing. They were decommissioning the whole plant facility and pretty much did demolition and segregated those different type of waste materials, building and piping and structural columns and everything imaginable. And a lot of that stuff moved towards salvage. So we looked at columns and supports, guardrails, process equipment, different filters, vessels, a whole lot of piping, a lot of yellow guardrails, steps, handrails, kick plates, bollards, fire monitors within the facility. Our range of we did a total of 66 bulk samples. And for the red fire monitors that had the red paint and or primer underneath it, less than 0.005% to 1.4%. Structural columns and beams had up to 1%. And we got a 6% lead content for yellow paint on a deck support. All right, so therefore the demolition contractor was made aware of this, and they were building this into their plans for how they're going to segregate and how they're going to get rid of these materials. So they were salvaging, selling a lot of it to get money back into the project for the client. So there was trade-offs going on there. So they wanted the initial survey results to kind of get a handle on what was shaking. All right, here are some of the bulk sample results. That column in one of the units had some lead paint on it, and that's the one that we got from a bulk sample of 6% lead. Here's some pictures. Again, beams, supports, columns, lots of different colors of paint. Under the top layers of paint, you see some red primer, you see some orange, you see some red. So this is kind of where flags were waving with respect to, okay, we're going to see some lead content going along with this. Here is the yellow one on the left-hand side, kind of that little kick plate on a deck grading close to some stairs going up to a different level that had the yellow paint, that had the 6% lead. And then other stair rails and guard rails and bollards and other type of supports also had lead paint. And you can see the red primer underneath. Again, guardrails, red and yellow are kind of our favorite colors to look for. So we did quite a bit of sampling for that and got quite a range of results, but tried to use that to make some generalizations regarding what we were going to see about those different items and issues. Conclusions, oh my goodness, I think I'm there finally. Hope I'm doing okay time-wise, think I'm hitting it. So my conclusions as a consultant and looking at it from a project scope of work and how can I meet the client's needs and give them the appropriate documentation, I would like to do pre-planning, and I would like to be able to zoom in on that specific project scope of work for hazardous materials and provide appropriate consulting service. So what is the scope? Are we doing a survey? Are we identifying hazards? Are we looking at existing control measures or things that are already in place? What are we going to do with this hazardous material information when we get it? And are we doing some exposure assessment to be able to look at evaluation and control measures? And if we're doing remediation, how are we going to say, yes, we've successfully completed the project and our employees are protected, and how we can give that data documentation to be able to drive that home. So challenges continue with regard to proper sampling strategy. It's not a cut and fit, put it in the box, same kind of thing that you're doing every time. So you kind of have to know about the facility and the history and the scope of work and what the client's going for so that you can get through what kind of survey methods do we want to use. Do we want to do swabs? We want to do wipes? We want to do bulk samples? We want to do some or all of the above? And how are we going to use that data to write and implement the appropriate health and safety programs if they don't already exist, okay? And use that for HAZCOM, for workers and other types of people that could have an exposure standpoint. How are we going to interpret that data? And how are we going to get towards the renovation and or remediation? And again, we have to check the boxes and make sure we have the written support for that. Lessons learned. There's a lot of different evaluation techniques out there. There's a lot of different types of hazardous materials. We're looking for the presence of lead. We can use a combination of different methodologies. We can do screening with the swabs. We can take bulk lab samples and send them to the lab and do some real analysis with some QA/QC and documentation for that. What's the industrial hygienist going to do? They're going to look at surveys and airborne assessment strategies. We're always looking for the health standpoint to be able to better protect the workers. And maybe in some cases, we need to look at that waste characterization. How are we going to properly dispose of stuff? How are we going to use the survey data if we are going to get to some type of remediation project, whether we're going to renovate or we're going to demolish the facility, and how are we going to segregate and get some of those materials through the salvage process, do it safely, do it properly, and disposed of appropriately, and what other types of regulatory requirements and other types of criteria may be available. I think I did it.
All right, thank you, Jan. If you want to keep that presentation up, you do have a question. Bill, do you want to help moderate the first few questions in the Q&A box?
Sure.
Thank you. It looks like Keel Kenning started it off.
Here's your first question. Jan, where do you find acceptable service levels of lead and other metals for wipe sampling? Where do you find the acceptable surface levels?
Yeah, that's my problem. I kind of alluded to it and I kind of glossed over it. I mean, some of the first things I looked at, if you're doing HUD housing, then, you can tune in and use HUD levels for clearance for windowsills and surfaces. My industrial facilities and my other things, I don't really know what to use. So some of the first references I used was a EIA, that Environmental Information Association. I'm going to date myself with the gray hair, obviously, because that one's been around a while with the ACM and stuff. We used to go to that conference. So they had some publications out there that listed the consumer product safety one, and maybe they didn't necessarily list the specific state of Texas one. I mentioned the DSHS one. So yeah, that's something I struggle with. I've alluded to different things in different surveys and, may not have necessarily picked the acceptable thing. So I think it's going to say, the OSHA lead reg, if you're doing demolition, says, it's all about exposure assessment and the airborne levels. So by doing the survey for the industrial plant and getting bulk levels, that doesn't tell you anything about airborne exposure. So theoretically, you're going to have to do a negative exposure assessment, do airborne levels with the full PPE and decon and shower and everything until you can show they're using proper work practices and procedures. Hopefully I got there.
I think we have a speaker later on. Freddie's going to actually be talking about regulations on lead, and so he's supposed to be touching on a lot of, like you said, the HUD things and other things, but he may hit some of that criteria as he's going through that. So the next question noted the lead air sampling results from the government firing range were labeled in milligrams per cubic meter, not in micrograms per cubic meter. Is that correct, or did I miss something?
Well, that's just a great question. I don't know. Let me micrograms. So when we reported the TWA thing,
At the firing range one.
yeah. So here was the airborne ones. So that said, oh, that says concentration, yeah, in milligrams per cubic meter. Oh, you're saying to compare to the OSHA is what, 0.05 micrograms per cubic meter? Isn't that OSHA? So yeah, this is in milligrams. So the lab reported it to us in milligrams. You're right, we need to make sure that we looked at it with regard to micrograms. So the white sample results were in micrograms per square foot, but okay, yeah, we need to look back in there and make sure that was in the right unit. We drafted the report and sent it to the big government guys, and they looked at it. So yeah, let me go back and look at my report and make sure we made the right transition.
All right,
And-
Bill, Jan, we're almost out of time, so if you can quickly take those last few questions.
Did you ever use a XRF analyzer to test for lead paint?
Oh, good point. I forgot about that. Yeah, we did. We brought in a third-party contractor in one case to do a large multi-building facility that was moving toward demo, and they did it on door frames and different kind of stuff. Yes, that's a great option. I should have included that.
And then comparing your surface wipe sample to what criteria? That's the HUD stuff?
If it's that kind of project, yeah.
Okay. I think that's it.
Okay, great.
Thank you. Very good.
Oh, you're welcome.
Thank you so much, Jan. All right, so Sylvia, if you would pass the ball to Dr. Carson. Next up, we have Dr. Chip Carson on lead exposure and human health through the ages. For those of you that don't know Dr. Carson, he was with us here at the School of Public Health for a long time. And he was the program director of the Occupational Environmental Medicine Training Program. Dr. Carson is a toxicologist and an MD, and he is now in Cincinnati and is the principal of Environmental Medicine Consultants. So welcome, Dr. Carson. You can go ahead and share your presentation and get started.
We're talking about lead, and lead, like all metals, has certain commercially useful properties, which has resulted in its distribution around the globe. Among these, for metals in general, are heat and electrical conductivity, which lead has, malleability, which lead is nearly the king of, not so high on luster and shine, as lead develops a dull gray oxide coating over a short period of time, and it doesn't have a very high tensile strength. However, it does have an extremely high density, which is why it's routinely used in things like X-ray and radiation shielding materials. And it is extremely stable in the environment. I, until recently, had a water distribution line coming into my 130-year-old house that was made of lead, and it's in perfect shape. I did replace it just because of the possibility of lead contamination in the water. And there are other properties that metals have that also make them desirable. And when speaking about lead, some of the chemical properties of lead are important, and we'll discuss those later. Next slide, please. Lead is one of the so-called heavy metals from a toxicity point of view. These typically comprise the first four in this list, and sometimes the fifth, chromium, as well. So lead, cadmium, mercury, arsenic, and chromium are typically the heavy metals of concern that we worry about toxicity. These metals are often also found together and can result in contamination during the smelting process of manufacturing lead metal or some of these other metals. And if the refining is not complete, they can also be transmitted to subsequent products along with lead. But these are concerns that we sometimes worry about when we detect lead, which is a common thing to look for. We also want to look for some of these other things to see if they have come along with the lead before we've identified a source. Next slide, please. I want to talk a little bit about where lead has come from around the globe. And the picture you see on the right side of the screen here is an aerial view of the ice cap in Greenland. Now, the ice cap in Greenland is hundreds of feet thick and represents snow that has fallen there over thousands of years and packed down into glaciers and solid ice. Well, researchers, much smarter than I am, have engaged in projects over time to drill core samples into this ice cap, pull out those cores and section them into time periods and analyze the materials that they find in the ice, which they can relate to snow that fell in Greenland during that particular period of time, represented by the place on the core sample. The graph to the left shows, although they've done this for the last 10,000 years, the graph to the left shows what's happened over the last about 300 years. And you can see there has been a sharp rise in lead that has been detected in the snow that fell in Greenland beginning in the early 1700s. And that rise is representative of the Industrial Revolution that was happening in Europe and in China and in a few other parts of the world during that period of time. And along with the Industrial Revolution, there was increased manufacture and use of lead. Because of that, much of it was distributed as particulate, very fine particulate or fume, into the air, circulated through the stratosphere, and eventually was incorporated into snow that fell in Greenland. And that represents an average distribution around the world. Now, they've also checked a couple of other things in these core samples. One of those was sea salt per kilogram of snow and calcium per kilogram of snow as controls. And both of those are flat lines on these core samples, showing they did not change over the last 300 years. But lead obviously has risen. You can also see on this graph that in the early 1900s, around 1930, you see a rapid increase in the evolution of lead into the environment. And this is occurring at the time that we began putting tetraethyl lead in gasoline as an anti-knock agent, which just completely blew us out of the water in terms of the amount of lead in the environment. Let's go to the next slide. This slide shows the contribution of lead paint and gasoline to lead entering the US environment from 1910 up until about 1990. You can see that the green line, which is lead paint, was high until about 1950, when the first legislation was passed to remove lead from paint because it was recognized as a toxin, and it was reduced to a low percentage, which was still permitted in paint. And in the early 1970s, that low percentage was eliminated to essentially zero in paint used in residential structures, and was only continued to be permitted in certain marine applications and certain structural applications like bridges and so forth. You can see beginning in 1930, as we began putting lead in gasoline, there was a rapid elevation of gasoline lead. And by 1970, gasoline had taken over as the principal source of lead entering the U.S. environment in general, until legislation was passed that removed that from gasoline, most gasoline. And you can see a rapid decline. And by 1990, very little lead was coming into the environment from either of these major sources. Next slide, please. So where does lead enter our environment? Well, historically, lead-based paint has been one of the principal sources of lead entering the environment. And in Jan's presentation earlier, she talked about assessing various painted surfaces for the presence of lead. And it's still found in a lot of industrial areas, and certainly is found on structures that are older than 1950 in their construction. And where you see this weathered paint in these older structures, and you can see the wood underneath, it's almost certainly lead paint that you're looking at. This paint is very friable and chips off, lands on the ground below, and is ground into the soil as powder. If this is a residential area or is frequented by children in particular, children that have a lot of hand-to-mouth behavior and spend a lot of time on the ground, are particularly at risk for picking up lead contamination and transferring that into their bodies. So lead-based paint was really the first recognized environmental hazardous source of lead exposure to the population. Let's go to the next slide. Lead was put into paint because it was recognized as simply the best substance for protection of a surface. And it was advertised that way. There were a number of companies, such as the railroad paint company, that provided materials and touted the benefits of their materials due to the lead content. And pure white lead is lead oxide, which is a wonderful pigment, which is very environmentally stable, remains on surfaces, wood, metal, what have you, for a very long period of time, and doesn't have to be renewed for up to 15 to 20 years generally. And it is now been replaced by other pigments. When lead was removed as a pigment, it had to be replaced by something that was close to it in terms of its protective ability. And so it's now been replaced by either zinc or, in most cases, titanium as a base pigment. Next slide, please. Lead has also been a principal substance used in plumbing. This is a picture of a Roman bath that was built about 2,000 years ago and is still in operation. The plumbing for this structure was made of lead, and the pools themselves are lined with lead foil, which lasts forever, basically. Well, 2,000 years at least. And so the term plumber comes from the Latin for meaning lead, plumbum, because plumbers used lead to in their trade almost exclusively. Plumbers also were responsible for building roofs using lead flashing and lead coverings that lasted for extended periods of time. You may have been aware of the recent fire of the at the Cathedral of Notre Dame in Paris that burned off the roof, and they estimated that there were 500 tons of lead that were lost in that process that disappeared somewhere into the environment, because that's how much lead was on the roof of Notre Dame. I understand it's being replaced in a lead-free manner at this point. Let's go to the next slide. Construction and demolition are one of the major sources of lead evolution into our environment currently. And when this lead paint, lead coatings, lead pipes, and so forth are removed from buildings before they are raised, or they are modified or added to during renovation or restoration, there's typically a lot of this lead waste material that is evolved into the environment. Here you see a guy who is scraping paint on a historic building. He's doing it by a wet method to reduce the amount of small particulate dust that's evolved into the atmosphere. You see he has a water spray bottle in his left hand. He's wearing a Tyvek suit, a full face respirator with HEPA filter, particulate filters. He doesn't have a head covering on here, which is something I would probably tell him he needs to utilize. But you can also see in the background here that the immediate vicinity ground surface is covered by a plastic layer, so that dust that does fall during this operation or chunks of lead can be gathered and disposed of as hazardous waste. Next slide, please. Another source of lead exposure that is still a concern in some areas is the production of moonshine, otherwise known as artisanal liquor. And this is principally because of the distillation methods that are used and the condensers that are employed in order to condense the alcohol-rich vapor from cooking the mash into the finished product that you see on the right side of the slide here. Before it was well appreciated by some of these proprietors, they used things like automobile radiators as condensing units in order to aid their production of these liquors, and the result was that there were often high lead contents in the liquors. We'll talk about lead in liquor a little bit more in a moment, but suffice it to say that you can still purchase moonshine. There is legal moonshine and there is illegal moonshine. And I would say that where I am living currently in Appalachia, both of those are easy to come by. And I would warn everyone that the buyer needs to beware in this setting. And if you have your lead test strips, you might want to use them on the moonshine. And next slide, please. A somewhat unappreciated source of lead exposure, which is more prevalent in the immigrant population in the US, is the use of cosmetics that contain lead. These are typically dark, jet black pigments that are used to outline the eyes and are sometimes also used in children. These are often known by the name kajal or coal, and there are adequate substitutes, lead-free substitutes for these cosmetics that are available. And I have seen in some ethnic stores or ethnic-oriented stores that they are now becoming aware of lead in cosmetics. And I've seen some signs posted that indicate that lead-free cosmetics are available, but the ones that contain lead are still available in many of these Asian markets. Next slide, please. Something that is fairly prevalent in Texas is the presence of coal-fired lead-glazed pottery, where the surface glaze from the pottery contains a significant amount of lead. These are pots that are imported by Central American immigrants that bring them with them as traditional vessels when they come into the U.S. You can also buy some of these in stores where they are exported from their source in Guatemala or other places in Central America and sold in the U.S. But it's when these are typically used for storing beans and things like that. But when they are used for storing acidic materials like juices or fruits, the acidic nature of the foods will extract a large amount of lead from the glaze on these surfaces and can then further expose people who consume that food. Next slide, please. Another source of lead is unfortunately the employment of traditional medicine by traditional healers in the Central American community. I've had a number of patients who have been fairly seriously lead poisoned by the use of azarcon or gretas that contain fairly high lead content. And we found some of these powdered remedies to contain as much as 70% lead compounds. So that is quite a big dose of lead. And there is always a campaign, an education campaign to try to reverse this practice, but these things continue to sneak into our environment. Next slide, please. Some of you may have fancy leaded crystal decanters and things of that nature. And high quality lead crystal contains as much as 70% lead. When you take a fine brandy, for example, or cognac or Armagnac, and you put it in one of these decanters and you let it sit for months or years, it does extract a significant amount of lead from the glass. You think that glass is fairly stable and that substances would not be able to really reach in and pull molecules out, but in fact they can. And so it's been shown that that spirits that are stored in these decanters for a long period of time can become contaminated with a significant amount of lead. So my recommendation to you is keep your fancy decanters, but either drink the liquor out of them quickly over a period of weeks, or just use them for show and fill them before you entertain guests, and then empty them back into the original bottle afterwards, so that the residence time of the fluid on the crystal is shortened. Next slide, please. The recycling of lead acid batteries is also a major industry and has become a cottage industry in a lot of places. There are a lot of garages in the Houston area that do this. They take old batteries, break them down, and essentially the only thing they're after in those batteries is the lead that remains, which can be sold to a recycler for a pretty good income. Unfortunately, in this process, there are many other materials that are generated that are highly lead contaminated, and the processes that are used themselves are not often done very safely. And so you find people engaged in these operations who become lead poisoned simply because of lack of education, because these are small businesses. They don't have the knowledgeable supervision or safety input that they should have, that larger businesses have the advantage of. And they also can cause a significant amount of environmental contamination. And I've seen some of these shops where there are also children running around in the within the shop or around the shop and becoming exposed to the dust and materials that are generated as a result of this operation. Next slide, please. These things pictured here are children's toys. The ones on the right, on the bottom, there's a model truck with miniature figures inside it. On the top right, there are a couple of dinosaurs, or several dinosaurs in this package. These are plastic-based models that are hand-painted and come from China. They're manufactured in China and imported into the US. And these are severely contaminated with lead from both the plastic contains lead that was used as a stabilizer during the manufacture, and the paint that was applied contains lead, and also in this particular case contained cadmium. So these things are Consumer Products Safety Commission and the U.S. Customs Department try to be vigilant about these things, but they still sneak through our borders and are sold and become sources of lead exposure to kids. The little pieces of jewelry to the left were also manufactured in China and imported. And these are marketed to little girls. These were actually purchased in a store called Claire's, which is a store that sells all things of interest to little girls, basically. And they were purchased there in Houston. Next slide, please. The way that I originally got involved with lead exposure and its hazard to health was through an experience that I had as a medical student. You may know that the 4 years of medical school in the US is usually broken into halves, where the first half is mostly didactic education, textbook learning, laboratory learning, and so forth. And in the last 2 years, you get inserted into the hospital, actually practicing medicine along with more experienced doctors. And in my third year pediatrics clerkship, I was in the Children's Hospital in Columbus, Ohio, and I was assigned a patient who was a 3.5-year-old girl who had been admitted to this hospital for chelation therapy because she had a high lead level. And this little girl had gone with her mother and her 1.5-year-old brother, who was a rugrat, to a local public health clinic where they lived in their neighborhood of Columbus. and because the little girl had an earache. It just so happened that at that point in time, there was a federally funded demonstration project there to measure all children who came into that clinic for any purpose, to take a blood sample and measure it for lead, just to do a general survey on what is existing in the population. Well, this little girl who had the earache came in, and her blood lead level was 57 micrograms per deciliter. That's an extremely high level of lead in the blood for a child, and indicates that there is significant toxicity going on in that little girl. Well, my job as a medical student was to go into that room and interview the mother about her child and do a physical exam on the little girl. Right after 4 or 5 other physicians in succession, first the clinic physician they saw, then the admitting chief resident in the hospital that they talked to, the attending in the hospital that they talked to, then the second-year resident, then the intern, and now the medical student. I was coming in after this little girl had been poked and prodded by a number of people, and the mother was just exasperated by all of the answering the same questions over and over again. So I thought I would do a little bit different kind of approach, and I asked the mother, among other things, what do you do for a living? Well, she told me that she was on public assistance. She got a welfare check every month, but she also got a little bit of extra money because there was a factory in the neighborhood, on the edge of the neighborhood, where she and some of the other people in the neighborhood would go early in the morning. They'd line up. They would receive a box full of parts that they would take home with them, and they would assemble these parts into finished assemblies and then bring them back the next day to the factory, and the factory would pay them a certain amount for each piece that they had assembled. And I asked her, well, what are you putting together? And she said, well, we're making pieces of a locking mechanism for money bags. These were the, they still exist to some extent today. These were the canvas money bags used by business that they put the day's receipts in, they zip it closed and lock the zipper on the bag with a key, and then they take the bag with them as to the bank and throw it in the night deposit slot in the wall of the bank on their way home. She was telling, I was asking her to describe a little bit about how she did it, and she says, well, I have these metal squares that have holes in them, and I have this nylon cord, and what I do is I take the cord and I thread it through the holes in these squares, and I was asking her, I was trying to understand this, what she did, and I asked her for some more detail, and could she write a picture, draw a picture on my pad? And she said, wait a minute, and she grabbed her daughter's toy purse, and she opened it up, and she reached in and pulled out a handful of these metal squares that were dull gray metal. And I looked at those, and she said she uses these as play money. And I said, you know, these things are lead. That's probably where she got lead exposed. So as it turned out, that was the source of the little girl's lead exposure. And there's more to the story, because as a result of this, not only did I have a really good story for rounds the next morning, but I went with the health department to this house, and we were able to do sampling there that verified the presence of lead. You could see the lead dust in the shag carpet that was tracked around the chair where she sat as she assembled these things, as the kids ran around the chair and through the house. And not only those kids, but it turned out she had a third job, which was taking in kids from the neighborhood whose mothers had jobs and needed a daycare for their children. So overall, we ended up finding 24 children in this neighborhood who were poisoned with lead as a result of this piecework operation at the factory. So that's how I got interested in lead as a toxic agent initially, and continued that in my practice for years after. Next slide, please. It's important to underscore that children are especially susceptible to lead poisoning, although they're not the only ones who suffer from toxicity. Adults do as well. We look at the next slide. This is a graph that compares health effects produced by lead in adults in green at the top of the slide, and in children in the buff color at the bottom of the slide. And the scale across the bottom is blood lead level in micrograms per deciliter of whole blood. And you can see that a number of the toxic effects are similar in children and adults. Encephalopathy, anemia at the very high levels. But as the levels decrease to lower levels of exposure, the types of toxic effects are different in children and adults. And this stems mostly from the fact that children have a developing nervous system up through the age of 8 and beyond. And so lead exposure beginning early in their lives can have a very significant effect on their neurological development, their eventual IQ, their hearing, their growth level, various other aspects of their development. Higher levels in adults result in neurotoxicity, but not so much in the cognitive domain, but in the functional motor domain. And one of the things that occurs in adults is peripheral neuropathy, male infertility, and kidney injury that results in things like wrist drop and foot drop in severely exposed adults. In the next slide, some of these things are listed in a little bit easier to digest list. These are toxic effects that occur in both adults and children. But one of the ways that lead does this is because it mimics certain other metals in biochemical reactions. It inhibits multiple enzyme systems and results in a disturbance of many of the normal biochemical processes that we need to live and function properly. Next slide, please. If we're trying to diagnose lead poisoning in an individual, we start with a history of lead exposure and try to elucidate all of the places in their activities or employments where they may have been exposed to lead or certainly were exposed to lead. We look at various signs or symptoms of the toxicities and the illnesses that were listed on the previous slide. We assess the biological level of lead through blood lead measurements generally. For long half-life metals like lead, we also need to assess the body burden, because the blood level only gives us the current toxic level to various body organs, but what it doesn't tell us is how much lead is in the body, sunk into the matrix of bones and so forth. And that's an important thing to know when we're trying to undo some of these processes and prevent further damage from lead exposure. And most important, and something that doctors are less capable of doing, is identifying the source of the exposure. And this is where we pair or partner with industrial hygiene to evaluate environments that we suspect are hazardous and quantify that level of exposure and eliminate it eventually, and potentially prevent the same kind of poisoning in others who may be exposed to the same environment. Next slide, please. This is an X-ray of about a 3-year-old child, and it's normal. You see the ribs at the top, the hips and thigh bones at the bottom. But what's not normal about this X-ray is the central area. You may see tiny little specks of bright white, which indicates very dense substances in those locations. Those tiny little specks of light should not be there, and they represent flakes of lead paint that have been ingested by this 3-year-old. Next slide, please. This is a couple of wrists from 2 different children. And again, these are in 3-year-olds. You can see that the wrist bones have not completely formed yet and are mostly rubbery cartilage at this stage. But because the bones are growing here, what you see is the edges of the bones are outlined by very bright white outlines. And this indicates that lead is being incorporated into those bones as they're growing. In the wrist on the right side, you see the ends of the radius and the ulnar bone are lit bright white. That's the epiphyseal plate, which is the growing end of those bones. Next slide, please. This is a couple of knees, again, from a child, and you can see the very bright bands on the lower level of the thigh bones there, the lower end of the thigh bones above the knee joint, and the upper end of the tibial bone just below the knee joint, which also indicates lead being incorporated into those into that skeletal structure. Next slide. This is a microscopic look at a blood smear. The smear on the left is a normal smear showing normal red blood cells of normal size. They're uniform in appearance. The other 2 show red blood cells that are paler and smaller than the normal ones. And this is a condition known as microcytic hypochromic anemia. In addition to that, you also see the presence of immature red blood cells called reticulocytes, shown by the arrows in these 2 panes. And when the body has low oxygen carrying capacity in the bloodstream, it may shove out immature red blood cells into the circulation in an attempt to boost that. But because lead inhibits the enzymes that lead to the formation of hemoglobin, it results in an anemia that has lower oxygen carrying capacity. So that's one of the main toxic effects of lead, even at fairly low levels. Next slide, please. I'm not going to go through the synthesis of hemoglobin, but just so you know, hemoglobin is a protein molecule that contains iron and is the structure that actually grabs oxygen in our lungs, carries it in the bloodstream in red blood cells to all parts of the body, and releases that oxygen where it can be used for all our cells. Next slide, please. In people who are lead poisoned, you can sometimes see what's called a lead line. This is unfortunately a black and white photo, but you can see in the gums a dark band that has formed, and this is typically black or blue-black in color and is known as a lead line. Next slide, please. This is actually a famous picture from the 1930s that shows a man with severe lead poisoning and peripheral neuropathy. And because the nerves in his arm are not able to tell the muscles to move properly, he is unable to raise his wrist. And this is a condition known as wrist drop. And the same thing is occurring presumably in his feet. So people who have this condition, at the early parts of this condition, will sort of drag their feet or scuff the soles of their shoes as this condition is developing. That can be one of the early signs. Sometimes they can come in complaining of weakness in their arms and wrists. But this kind of lead toxicity rarely is seen in the clinic anymore because we are getting smarter about lead exposure. Next slide, please. Based on data from probably the best evidence that we have, which is the NHANES studies, which have been running in the United States from about 1980 up until the present time, and contain data that reaches back into the 1970s, they've been looking at large populations of people in the US for lots and lots of different environmental contaminations, including lead poisoning. Currently, based on the last available data, which is 2019, the geometric mean for blood lead and a representative sample of US adults greater than 20 years old was a 0.92 micrograms per deciliter. So right about 1 microgram per deciliter. If you recall that child who came into my clinic, she was at 57. So that's 57 times higher than what's normal for adults. And the current mean for blood lead in children is even lower, 0.75. This is a dramatic decrease that has occurred over the last 2 decades as a result of removing lead from paint in residential structures and removing it from gasoline, and has resulted in a drop in the average blood lead of children and adults from between 10 and 20 micrograms per deciliter to below 1 microgram per deciliter in both of those groups. And this is considered a great success from a public health perspective, but it ignores the exposure to small groups of people who may be exposed to particular industrial sources or particular environmental contamination sources. Next slide, please. This is a case that I had, and we've already heard about a similar case from Jan in her previous presentation, but this was a 45-year-old lawyer who came in to see me, who complained of early fatigue, abdominal cramping, joint pains, and malaise. And she felt so bad that she had stopped practicing law and just stayed in bed all day. That's a condition we refer medically to as malaise. She also reduced her hobby that she was just passionate about and her cardiovascular exercise program. She ran every day. She engaged in her hobby several times a week. She appeared weak, pale, and concerned. Okay, next slide, please. I talked to her about her past medical history, allergies, family history. Nothing seemed to be to light up as a clue there. She did have some recent international travel to Sweden in conjunction with her hobby. Her physical exam was normal, except that the membranes of her oral cavity were pale, and so were the membranes around her eyes. We tested her stool for occult blood to see if she was bleeding from the GI tract, which is the most common cause for findings of relative anemia, which were suggested by her oral and conjunctival pallor. That was negative, so she wasn't bleeding in her gut. So I imagine everybody is sort of interested in what her hobby was. Next slide, please. We did some basic laboratories on her. Her serum chemistry was normal. That's a dozen or so things, chemicals that we measure in the blood serum that indicate organ damage or malfunction. But we did a blood count. This is where you count the number of red blood cells, measure their size, the number of white blood cells, and so forth. The only abnormalities on that was that she had very small red blood cells, that's the MCV, and her cells were averaged 68 femtoliters in size compared with normal of 89. And her hemoglobin was dramatically reduced at 9.8 compared to a normal of 13.2. And there were also reticulocytes, those immature red blood cells that were seen on her smear. So next slide, please. Her blood lead level, which we did immediately following that, was 56. So she was in about as bad a shape as the little girl that I talked about earlier. And something called zinc protoporphyrin was elevated. This indicates that the synthetic pathway of hemoglobin is stalled, and that was due to her high blood lead level. We did an IH survey of her home shooting range, which disclosed heavy lead contamination and high air levels. As it turns out, this lady was a world-class pistol target shooter. And every day she would, or 3 or 4 times a week, she would drive 8 miles to the shooting range where she practiced. She would discharge 250 or so rounds of ammunition at each shooting, couple of hours of shooting. And then she would come home again. Well, to be nice, her husband, for her birthday, had a home shooting range built in their garage, so she wouldn't have to make these 8-mile trips several times a week, and they'd have more time together and so forth. Unfortunately, they didn't take into account the hygiene measures that also needed to be taken, the personal protection, ventilation, engineering controls that needed to be included. And so, unfortunately, she poisoned herself by her hobby over a period of about 6 months. We got the shooting range cleaned up, and they installed some remedial ventilation system that should probably keep it fairly hygienic, and promised to do repeated assessments over time. As far as she was concerned, we gave her a course of chelation treatment. Actually, this slide is wrong. DMSA is dimercaptosuccinic acid, which is an oral chelation treatment. Chelators are chemicals that go in. We we pump them into your system. They grab these metal ions and pull them out, in this case, into the urine, so you can drag metals out of the body and essentially reduce the half-life in the body. We actually did 3 5-day courses of DMSA with her that brought her to a rebound level of 32 micrograms per deciliter 3 weeks later, that's recognized as a success and means that we will continue. She has a significant body burden, and we will continue to give her chelation treatments probably for about a year until she is able to pull enough lead out of her body that she comes back down toward the normal level of lead. Next slide, please. These are some references for your use. There are some interesting things in here. And regarding firing ranges, there was an article that was published in the Morbidity and Mortality Weekly Report, which is a CDC publication, which is about the middle of that reference list regarding indoor firing ranges and elevated blood lead. This is an emerging source of lead poisoning in this country. As the popularity of shooting at firing ranges increases over time, the number of people exposed, the number of people employed in these ranges, and the number of ranges that are inadequately controlled are increasing nationwide. So this is an area that we need to look to as a future source of lead poisoning, which may be increasing. All right, that's all I have for our talk today. I'd like to ask if there are any last-minute questions.
Thank you, Dr. Carson. Our panelists, if you would like to ask Dr. Carson any questions, you can just feel free to unmute yourself, turn on your video, and for our attendees, please enter those questions into the Q&A box.
This is Bill Young. I was going to mention or throw a question at you. One on chelation or the lack of chelation. If a person has a blood lead level or bone levels of lead, will they eventually will they get eliminated from the body over a long period of time, or do they continue to stay there for years and years or decades?
Well, the half-life of lead in adults is between 10 and 15 years. So the amount of, if there's no further exposure, the amount of lead in the body will continue to decay over a long period of time. But if the resulting blood lead level is high enough to produce toxicity, that toxicity will continue to occur all during that elimination time for decades. And so it really does become a medical emergency if that level is high enough to produce damage to end organs. And typically we will not chelate people who have blood leads less than about 30. We may be moving to a lower criterion at some point in the future, but about 30 micrograms per deciliter is the point at which, in my opinion, and those of a number of other toxicologists, believe that there's significant end organ toxicity occurring, including neurologic issues. And so we will chelate those people to reduce that that half-life and draw down the blood lead quickly so that they can avoid that.
Thank you, Dr. Carson, for your presentation and for your time and service today. And we are going to move to a break. Welcome back, everyone. We are going to go on to our third speaker of the day, Mr. Brian Stott, who is president of Risk to Reward Consulting, and he's going to be speaking on industrial hygiene lead awareness. Brian is a former Senior Director of Global HSE at McDermott International, and as I said, President currently of Risk2 Reward Consulting, and has over 30 years of project, corporate, health, safety, and security, and environmental leadership experience. So thank you, Brian, for being here with us today, and your presentation looks good, so take it away.
All right, well, thank you very much for the introduction, Michelle, and good morning and welcome to Industrial Hygiene Lead Awareness, Industrial Operations Involving Lead Exposure. I thank Michelle for that introduction, and here's just a little more information about my background. In addition to my 30 years of experience, I've had a fair amount of international experience. About half my career has been working internationally, mainly for the energy infrastructure and petroleum industries. And most of my experience with lead exposures comes from above ground storage tanks, both in the maintenance and demolition side of the business. So that's where I get involved with lead, or used to get involved with lead in fairly significant amounts. Also, a little bit on the leaded gasoline storage. A lot of times storage tanks that needed to be repaired that were in leaded gasoline storage service could also present some risk. So I've got a little bit of experience on that side of it too. So enough with the bio. Over to the lawyers now. Here's our disclaimer to keep our lawyers happy. And before I jump into our topic, I would like to just take a moment with all of you to have a safety and health moment. This one is actually a mental health moment. September is Suicide Prevention Month, and in fact, September 10th was the main day of the month where we raise awareness about mental health and suicide, its causes and prevention. And there's probably nobody on this call right now that hasn't been touched in one way, shape, or form by mental health issues, either within the family or people we know, or perhaps suicide. And it is a public health concern, especially in construction, which has 4 times higher than the general public when it comes to mental health challenges and issues. It's certainly been compounded by risk factors from COVID-19. And a few statistics here on suicide. It's the 2nd leading cause of death among young people and the 10th leading cause of death in the nation per the CDC. Every year in the U.S., more people die by suicide than in car accidents, and more suicide deaths than homicide and AIDS deaths combined. So something that shocked me when I was looking through these stats was about the 6th bullet down. For every person who dies by suicide annually, 316 people seriously consider it, but do not follow through and kill themselves. So since 2005, the Lifeline, the Suicide Lifeline, our suicide prevention lifeline, has received over 20 million calls from people in distress looking for help when they need it at most. And I share the lifeline phone number with you. It's over on the right. And then if you need some additional resources to refer to, I've listed a few down below here. So this is a health crisis around the country, and it's something that's on the increase. And I also think that when we talk about lead exposures, it's got a bit of a thread into mental health wellness, because as Dr. Carson had mentioned, high exposure to lead, high blood lead, those things can lead to some mental health issues and some damage to the nervous system. So we'll talk more about that later, but I just wanted to just take a moment and have this safety and health moment with all of you. Feel free to share it and or the resources that are with it. So the learning objectives of this session include effectively recognizing, evaluating, and controlling lead exposures, describing key industries where lead exposures can be found. We're going to talk a little bit about environmental considerations, although I know that will be talked about later when it comes to mitigating lead hazards and impacts. And then I'm going to share with you some potential challenges and successes for managing the global lead exposure program in the company that I had worked for. Just see. So I kind of want to start with a foundation. I don't know everyone's experience on the call with lead. I'm going to assume that you have some fundamental knowledge about it, but I'll start with the basics and build on it. And some of this may duplicate a little bit of what Dr. Carson and or Jan had shared, so I'll skip over those parts. But basically lead or plumbum was discovered somewhere around 7000 BC. It was actually extracted from ores containing silver. Nobody was chasing after lead at that time. They were actually chasing silver, but they were getting lead ore coming out of the mining operations that they had at that time. Very basic, I'm sure. Then you know, the Egyptians kind of commercialized lead a little more into cosmetic type products, eyeliner. That spread to Greece and beyond, and now lead today has many, many uses. Lead is a heavy metal. It's soft and malleable. It's ductile. But one of the great things about lead is its corrosion resistance. That's why it was used early on. Is it really didn't rust. It would oxidize, but it didn't rust and degrade like steel or iron and other elements. So when it's freshly cut, it is a little silvery with a hint of blue, but it does tarnish to a dull gray color. Obviously, it's on the periodic table of elements. Its symbol is Pb. Its atomic weight is 82, and its atomic weight is 207.2. Physical properties, we talked about it being dense in the previous presentation, and yes, it definitely is dense. That's what makes it great for radiation shielding, but it also has a low melting point, so it makes it a little easier to work relative to other metals. So why is lead exposure and health risk? You know, when we talk about industrial hygiene, one of the first steps of industrial hygiene is anticipation. So anticipating what the risks are. And in order to anticipate what the health risks are, you have to have some kind of fundamental understanding of the hazard or the product or the chemical that you're talking about. So when it comes to lead exposures, we need to have that understanding. So lead exposure is a global issue, and it's because it's mined and smelted and used in battery manufacturing, disposal, and recycling. It's very common in many countries around the world. Both developed and undeveloped countries have some element of lead type work going on inside their borders. Lead enters the body through three primary routes, mainly through inhalation, but it can be ingestion, as we saw earlier, and also skin absorption. When we talk about organoleads or organic lead, those can be absorbed through the skin. So that's an additional risk to consider. Lead is hazardous to humans and the targets and vital organs, including the eyes, GI tract, the central nervous system, the kidneys, blood, and gingival tissue. The photograph from the previous presentation was showing the lead lines on the gum tissue. That was a eye-opening photograph there. Exposure can cause lead poisoning. Obviously, the metal can also hamper the growth of organs in the brain in young children. And I think Dr. Carson had some really good examples of that. Almost all of the inhaled lead is absorbed into the body for ingestion. The rate's around 20 to 70%, with children absorbing a higher percentage than adults. Lead is also a neurotoxin that accumulates in soft tissues, blood, and bones. That's very important, as we saw earlier, that it can accumulate and have effects over a long period of time. It does damage the nervous system as well as interfering with biological enzymes. And it also affects general health, cardiovascular, and renal systems. I won't spend a lot of time on the acute and chronic effects. We saw that wonderful graph by Dr. Carson showing both adults and children and what the effects are. But, you know, one of the things I will say about these symptoms and signs of lead exposure or overexposure is they may occur slowly and be caused by other things. So lead poisoning can be easily overlooked. It may not be the most apparent cause of the issue, so it may take some time to diagnose and eventually treat. But there is, you know, cases where people have been exposed to very, very high levels of lead over a short period of time, and that can cause acute encephalopathy, leading to seizures, coma, and cardiac arrest. So you know, even short duration exposures at very high levels can have dramatic impacts, including death. And we'll talk a little bit more about that later. Some chronic effects. This is a nice graphic. Gives a little bit of information around all the various target organs that lead can impact within the body, starting with the brain, the digestive system, the nervous system, the body in general, fatigue, aches and pain, cardiovascular, kidneys, and the reproductive system. And then over in children, it can impact those same systems, but children not having the ability to, you know, they're still in the growth and development stages. They are susceptible to greater impacts from lead exposure, and that's something that we saw in the 1950s, 60s, and 70s when children in urban housing, and we'll talk about this in the notable cases coming up. People, our young children, were, you know, eating the lead chips and getting high exposure, or being exposed to lead dust inside their homes. So when we talk about the chronic effects, people with prolonged exposure to lead may also be at risk for high blood pressure, heart disease, kidney, and reduced fertility. Exposure can cause anemia, weakness, and kidney and brain damage, and very high lead exposure can cause death. The DHHS and EPA and the IARC have determined that lead is probably cancer causing in humans, which you know, is of concern, especially when you realize that the half-life of lead is so long and it takes a long time to basically be excreted out of the body. So let's jump into lead types and being able to recognize some of the hazards. We talked early in the first session with Jan about inorganic lead. It can be a dust, it can be a fume or a mist, and that's usually either metallic lead itself or lead additives to paints. There's lead carbonate, which is considered white lead. There's lead tetroxide, which is red lead, and lead chromate, which is, they call it chrome yellow. So we talked earlier, I think it was Jan, showing some photos of paints that, you know, red paints and yellow paints. And these are some of the ingredients that are put in paints to, one, they are put in for pigmentation, but their main purpose of being put in paints is their corrosion resistance. They coat steel and metals and prevent those from rusting, and that's what makes lead such a valuable commercial product is some of that corrosion resistance. On the other side of that is organic lead. Organic lead can be a vapor or fume. It is dermally absorbed in addition to being inhaled, or hopefully you're not ingesting it. But it comes in a variety of forms, including tetraethyl lead and tetramethyl lead. And those, as we had learned earlier, were used as anti-knock and octane boosters, additives in gasoline that are still used in high-octane fuels in aviation for piston engines to this day. And so we may have gotten rid of lead, organic leads in our automobiles and whatnot. That's a good thing, but it is still used in other forms of transportation, so it's not completely eradicated. Switching gears a little bit, just a little bit of history, and some of this was touched on earlier. Some notable lead exposures include one of the first metals used by humans, consequently caused the first recorded occupational disease, which was lead colic in the 4th century BC in metal workers. So that's the first recorded occupational disease, which I don't know if I had learned that earlier in my career, but when I saw that, I was like, man, this has been around for a long time, and it was the first occupational disease back in the 4th century BC. Lead was used by the Romans in paints and water pipes and food and beverage storage vessels. You know, the Romans were famous for their aqueducts, and we saw their soaking pools, and they lined those water vessels and food and beverage vessels with lead because, again, of their corrosion resistance. But as over time, the lead leached out and would cause lead poisoning. It was consumed, and mainly through ingestion of the people who were either eating or drinking food items or liquids from those storage vessels that were lined with lead. Kind of fast forwarding quite a bit, many homes that were built prior to 1978 had lead paint, especially during the 50s or prior to the 50s. We learned that it started to be phased out, and it took quite a bit of time to do that. There were an estimated 24 million homes across the United States that have lead-based paint. Exposure to lead dust, paint chips, and lead contaminated soil around the homes is what caused the elevated lead levels of lead in children exposed to the lead dust, of course, in eating paint chips. That's a lot of homes, and it's still a problem to this day. Although we're not painting homes necessarily with lead paint, there's a lot of homes out there that are older that still have lead paint on their exterior that can lead to exposures. My fourth bullet there is really around the last, major human exposure to lead was the addition of tetraethyl and tetramethyl lead to gasoline. That started, in around 1921. It was phased out by the U.S. and EU in 2000, and then I read on the AIHA catalyst here recently some news that was shared was regarding the final holdout. The country of Algeria used up the last of its leaded gasoline, and that's according to the UN Environment Program, which has spent about 19 years trying to eliminate leaded gasoline around the globe. So, you saw those high lead levels in the Greenland ice shelf that Dr. Carson shared, and that really resonated with me when you saw that spike up on the curve, and that was primarily due to the lead in fuels, automobile fuels. Now we're a century after it was developed and 50 years after its dangers were established. At least we're getting it out of street vehicles, which is great. The photos down below, the photo on the left, just to give you an idea, is what lead can look like, lead ore, or the metallic lead in the ground. And then over on the right-hand side, that is a catalytic converter. So virtually all of our engine-driven cars, not battery-driven, but engine-driven, have a catalytic converter now. When they removed lead from the fuel, now we have catalytic converters. And in fact, catalytic converters are popular for another reason, unfortunately, at least down here in Texas, is people are stealing catalytic converters off of vehicles because of the precious and exotic metals that are located inside them. So kind of famous for another reason, but catalytic converters came about as a result of removing lead from the fuel. So a little history on lead. Potential exposures in industrial operations, 7,000 BC, 7,000 years ago, we're talking about, they find lead in with silver ore and don't have a use for it really. They're more interested in the silver. But today, lead is, as we've seen, used in a lot of products, certainly in car battery manufacturing. It's a major ingredient, lead acid batteries, and we saw a little bit about that in recycling in an earlier presentation. Metal foundries, smelting, and ingot manufacturing. If you looked at the first slide that I'd put up, you saw a bunch of lead ingots over on the left-hand side, and that's what ingots look like when they're fresh and come out of the foundry, but they do oxidize and turn gray. Solder manufacture and use, including soldering parts of electrical equipment. Lead is also used as electrodes in electrolysis processes, including manufacturing of ammunition. Alloys are usually mixed with the lead in some ammunitions, and then as fishing weights, or what we call sinkers down here in Texas. Another important industrial operation that lead exposures can be prevalent in is waste management, and recycling. We talked about lead recycling, and it seems like everything ends up either recycled or going to a landfill or to a waste disposal site. So lead, what you produce ends up somewhere, especially when it's no longer needed or used. Underground storage tanks and above ground storage tanks, interestingly enough, can contain lead paints and primers on their exterior, but also, depending on the age of them, they could have had organic lead, leaded gasoline inside them, stored inside them. And so you can have lead on the inside and lead on the outside in those cases. Certainly construction remediation work where sanding, painting, scraping, cutting, burning, welding, or abrasive blasting is used. The arts and entertainment industry. I was looking at some data, air sampling data from OSHA, and I think the arts and, construction was, I believe, the highest exposure based on OSHA's sampling database. It was construction and manufacturing, and I think arts and entertainment was like the fourth leading industry where exposure to lead occurred per the sampling that was conducted by OSHA. So that's one that kind of caught me by surprise. And then building materials such as pipe, cable, coverings, and solders. Obviously, older water supply systems still use lead to this day. They have lead line pipe. lead solders these pipes have been underground for decades, literally decades. And I'm talking 50, 60, 70, maybe 80 years, a long, long time. So some of those supply systems still are a source of lead contamination. Also, lead is used, as we said, in radiation shielding. That's because of its density factors. And industries storing and using organic lead fuel additives, as I'd mentioned earlier, the aviation industry and certain other industries may be using it as well. But even though it's primarily gone out of our traffic, our cars and trucks and whatnot, it doesn't mean that folks are no longer using it. So I want to change gears a little bit here, and let's talk about occupational exposure limit standards. This comes in the evaluation stage, so we have anticipation, recognition. Now we're in the evaluation phase, and OSHA has obviously PELs for about 400 substances. And the PELs for lead can be found in general industry in 29 CFR 1910 1000, but also these are sources of exposure limits within OSHA. You have the construction in 29 CFR 1926. 1101, maritime 29 CFR 1915 1000, and then you have the substance specific standards. And lead is found in general industry in 1910 1025, construction 1926.62, and then shipyards in 1915 .1025. So you'll find a lot of information about OELs. These are just the OSHA ones. We're going to talk about a few more here that I've tried to put into a table that helps. So when we're evaluating lead exposure and occupational exposure, we need some basis or some baseline or some standard to compare it against. Well, I've listed here the ACGIH, NIOSH, and OSHA occupational exposure limits, and also the blood limits that have been set by both ACGIH and OSHA. But you'll see that they it's good to see OSHA and NIOSH and ACGIH at least all align on a TLV TWA. You don't see that across the board for a lot of chemicals, and there's reasons for that. But the current OSHA PEL time weighted average is 50 micrograms per cubic meter, and the action level is 30 micrograms per cubic meter. So one of the things that you do need to take into consideration is reducing the PEL for shifts longer than 8 hours. And there's a formula for doing that down at the bottom here. But these are the various OELs that are available for people to use and reference against. But OSHA obviously being the one that carries the legal enforcement here in the United States. So when we talk about evaluation, there's usually some way to sample for lead. We have to have a way to take a sample for lead to be able to evaluate that sample and compare it against a known standard so that we can either determine whether we're in compliance or out of compliance, and if additional controls are required. We had mentioned, I believe it was Jan had mentioned about the lead check swabs. They're more of a qualitative, I call it a go, no go, as far as whether or not there's lead. Very quick and easy way to determine if lead is present in in paints or in surfaces or in coatings. According to the literature, it indicated it could detect lead down to 600 parts per million. There are bulk samples. We talked about that. When you talk about paint chips or bulk samples for lead, I recommend a 1.5 inch by 1.5 inch, section of paint or coating for lab analysis. But I will put the caveat in there that you should always contact your lab when providing bulk samples, because they may need more than that. So always talk to them ahead of sampling, so you know how much surface material they're going to need for the bulk sample. There's also soil sampling, quantitative, and I highly recommend that if you're ever involved in any lead, let's say maintenance work involving lead on structures or doing any demolition, always do a prior to work or prior to starting work to see if the site's already contaminated, and after the work is completed. If you just do it after the work is completed and don't do any soil sampling up front, you're running the risk of perhaps even owning the contamination for all of it, and it could have been a lot of the contamination could have been there for years prior to you arriving on site. So when you think of a large above ground storage tank that's maybe 80 years old, 100 years old, how many times has that tank been blasted and painted over the years? And I can tell you that my experience is it's many, because I've seen multiple layers of paint, and a lot of times back prior to the 1980s, a lot of times when they blasted these tanks, they did it in open air and the dust just fell on the ground, and that was it. So be aware of that, and that's a recommendation that I think is just good practice, but before and after. And then air sampling. When we talk about full shift air sampling with high flow pump, usually around set at 2 liters per minute, and a mixed cellulose ester filter. There's some OSHA requirements around the air sampling and the number of samples you need to take as a minimum. I've listed those there. Need to conduct it every 3 months if above the PEL. So OSHA has in their lead standard has quite a bit of detail. If you haven't looked at it, I suggest you look at it thoroughly before you jump into any lead work, because it's got a lot of details and requirements. Obviously, you need to inform people when you're doing sampling of the results of that, and within 5 days of receiving the results. So for those of you who may not know what a high flow air pump looks like, over to the right there's one with the filter cassette and the tubing, and that's very common setup to use for air sampling lead. All right. So let's talk about some controls. Shifting gears again into controls. Obviously, following the hierarchy of controls is best. If you can eliminate or substitute, that's great. But in a lot of cases, we're dealing with structures that have been around for a long time that have lead or have had lead on them. So we can't necessarily eliminate or substitute. We're more probably can start more at the isolation stage. And I say isolation in that there are small components that if you determine they're covered or coated with lead-based paints, you can put them in blast booths to blast them where you're removing people out of the harm's way, and you're blasting it in in an enclosed booth that's isolated from people, therefore not exposing them. In most situations, you're probably going to rely on some form of ventilation. In large spaces, exhaust ventilation through a filtration media, a HEPA filter is certainly recommended, along with local exhaust ventilation for workers. Vacuum shrouded tools are also a great way to minimize exposures. And here's the photo on the right shows a grinder with a vacuum shroud that allows you to do some grinding and have all the particulate matter that is generated as a result of the grinding operation collected through a vacuum. So the person operating that tool is not, being exposed to the dust and debris that's being ground off the surface. There's also chemical paint strippers. Some of you may have some experience with those. Chemical paint strippers are a chemical applied to the paint itself and will basically eat away at the paint to the point where it's like a gel, and then it can be scraped off. There's also long-handled cutting tools and torches. In my business, or my former business, we had to do a lot of cutting on structures that had contained lead-based paints, and we do the blasting 6 inches each side of the cut line where we're going to cut with the torch. But another control we could use, or did use, were long-handled, extended-handled torches to try to move the person further back from the operation of cutting, because that's where you can convert a lot of the lead, any residual lead from a dust, or if it's in a coating that gets heated up, it can turn into obviously lead fume, and then people are breathing it. So a couple of, or several engineering controls there, and those are always better than some of the next controls we're going to talk about. Administrative controls, obviously the lead standard requires a site-specific exposure control plan, and there's a lot of elements that go into that plan. And the one of the best things you can have is a good plan, and then execute that good plan. So the photo on the right shows you a typical, I won't say a typical, but I'll say what appears to be a very well planned out job from the PPE that they're wearing, which is kind of the lowest form of protection. You also see a water bottle there. And we'll talk about that here in a minute with some work practice controls, wet methods, and whatnot. But looks also, if I'm seeing that correctly, it looks like a sampling cassette and a hose going over their left shoulder. So, and a pump maybe on their left hip. So this is, it looks like a residential lead abatement type activity. And then one of the things that you'll find that's very, very important is the annual training required in the lead standard. So when you have people who are engaged in the abatement process, they have to undergo annual training, and that's pretty critical and a very important administrative type control. When we move into work practices, there's a variety of work practices that are recommended in the OSHA standard. And some of these methods here, wetting methods, to minimize dust, keep it down. Housekeeping, and that's very important. Using a HEPA vacuum in the work area, the lunch area, and the change areas to keep them clean and keep exposure to lead containing dust down. You have to have designated change areas and showers. You can't be changing in the work area. You need to basically and have showers. Clean eating areas is also important. We talked about one of the entry routes of lead being ingestion, and people who don't wash and clean up when dealing or handling lead, or who may have lead on their hands if they go and eat or use tobacco products that they put in their mouth. Things like that can then ingest the lead and become exposed. So those are just things to keep in mind. We've got wash stations, obviously, we talked about, and then welding, cutting, and heating practices. So whenever you're volatilizing or potentially volatilizing the lead in the surface or the coating of a paint or a primer, you want to strip it back, either chemically or hydro or abrasive blasting, at least 6 inches of the cut line, and that's just to remove so you don't volatilize any of the lead that's in the coating and end up inhaling it. Obviously, you can use a temperature stick. They call it temperature indicating sticks on steel to check the temperature, keep it below 500 degrees Fahrenheit at the strip line. And as you saw earlier, we saw lead had a relatively low melting point, so you want to keep the temperature below that melting point so you don't volatilize the lead. And then obviously using airline respirators if exposure is greater than the OEL. Photo on the left is a HEPA, is a vacuum with a HEPA filter that can be used in cleaning up areas where lead is present. Last but not least, when we talk about lead exposure controls, is PPE. And if possible, I always recommend, look at the safety data sheet. For older products, tanks and whatnot, like what I was used to, that they were MSDSs, right? Back in the day, and how they're SDSs. But you want to make sure people are protected whenever they're working around lead. And that includes, gloves, glasses, coveralls with hoods and booties. And if they're in the construction business, hard hats are always recommended there because of the risk of bumping your head or something falling and hitting you. Some other things I recommend is obviously on the whenever you're conducting air monitoring or air sampling and using SEGs or similar exposure groups data, you can use SEG data provided it meets OSHA's criteria for respiratory protection level. The minimum protection is a half mask HEPA air purifying respirator. That would be the absolute minimum. The PAPRs, or powered air purifying respirators, can be useful, especially in welding and hot work where lead is volatilized. I suggest airline respirators as a start until you have good sampling data to rely on, and then work your way down to a lesser form of respiratory protection if it makes sense. Obviously, supplied air respirators, if you're doing any kind of abrasive blasting, is very, very important. And then respirator protection does increase as exposure potential increases. So, you don't start out with the minimum. You start out with the maximum level of protection and work your way down unless you've got good data, good air sampling data that suggests otherwise. Biomonitoring, we talked a little bit about that, so I won't spend much time on that. OSHA does require it if people are exposed over a certain amount, and they also require medical removal. And you do have to remove a person from the work if their blood lead level is above 50 micrograms per deciliter. So there are some requirements around the blood lead levels and ZPP levels and testing required. I believe years ago, OSHA used to approve the labs for blood lead monitoring. I don't believe they do so anymore. I think when the standard was new, they did, but now they've become maybe more comfortable with the capacity of labs to be able to, or medical facilities to be able to measure blood lead. So just be aware of that. When we talk about analytical methods, and I apologize, this slide is busy. It's got a lot of information on it, but I wanted to put it all on there just so you had it as a reference, because I know this is being recorded. So there's a lot of information available out there around analytical methods, but let me give you just a couple of key pointers here. If you're doing in-house laboratory analysis, and this is usually bigger companies that have labs, you know, oil and gas companies have their own labs in a lot of cases. Other companies, hospitals, etc., have their own laboratories, so they may be able to do on-site analytics of air samples. But I recommend you use an AIHA accredited lab where possible. Just make sure you're very specific when talking with the lab. I think Jan alluded to, you know, developing a good relationship with them and making sure they understand exactly what you need to do or what you want to sample for, and they'll give you guidance on what they need to be collected. Also, in the results, or in the when it comes to getting results from the lab, you want to make sure they put it in units that make sense to you. Chain of custody can be a challenge. I'll talk more about that here in just a few minutes, but especially when shipping internationally, it's a lot better today than it was back when I was in the Middle East doing a lot of sampling, but it can be a challenge, and I'll give you an example of that here in just a few minutes. Both OSHA and NIOSH have analytical methods developed for lead, and there's a variety of them. So I've just listed those here. I'm not going to go into any detail on those, but there are a variety of methods for both lead in air, for bulk samples, for wipe samples, for blood and urine. So I've just listed these that I could peel off of the websites for your information. Environmental aspects of lead, just to kind of give you the full spectrum. It's not just about protecting people, although that's first and foremost. We have to also protect the environment. I know there'll be more information in a later session on this, but soil sampling is certainly something that you'll want to do if you're in working with lead on remediation projects, and site air monitoring. That's important as well. Remember the pre and post work soil sampling. I wanted to stress that because you could be on the hook for someone else's contamination if you didn't do any pre-work soil sampling. Debris containment's very important, being able to contain your debris, whether it's blasting dust or you know, if it's scraping or grinding or what have you, just containing that. And from a waste disposal perspective, just make sure you're following the federal or state EPA requirements, using impermeable bags and labeling lead containing waste. Some waste may be hazardous and have to go to a regulated disposal site. And then I as a company that I represented, we always took the approach that the owner of the site that we were working was responsible for the disposal of the waste. So if you can arrange that, that's great. You don't want to take ownership of that unless you absolutely have to. Was there a question?
Not that I can see yet.
Okay.
Yeah, I don't see any either.
I thought I heard someone speak. So this is pretty close to my last slide here. Want to talk about managing a global program. Looks like I've got a few minutes left, and then we'll take some questions. Managing a global program, a lead exposure control program. It's great from a lot of aspects, but it has its challenges, and I'll just share with you some of my experiences with it. First and foremost, if you're involved in lead exposure control, identifying potential lead exposure and conducting a preliminary risk assessment is paramount. Learning about the history of the structure, the facility, the age of it, that can give you some insights into whether or not lead may be present and where it may be present. Also, the previous experience, I'll say service experience, or what the facility does. You know, are they a producer of leaded gasoline, or are they do they have a manufacturing process that involves lead? So understanding the actual facility is important, and then of course safety data sheets. Some companies, some facilities are better than others at maintaining those, especially if the facility's been there for 50, 60, 70, 80 years. Some of our refineries are that old. Maybe not in other industries, but certainly in the oil and gas industry, you can have some pretty old facilities. Identifying similar exposure groups, that's very important. When you're managing a worldwide program, you know, you want to look at the collective data set that you have around the world and see if you're able to establish similar exposure groups. And that's usually work dependent, right? What type of work they're doing. We were able to develop, you know, several kind of key groups, depending on what their work was, whether they were welding on a structure with a lead coating, or if they were grinding. So you can almost break it down by task if you have enough data, and it's really good to be able to have that if you can, because you can use historical air sampling data, provided it's the same working area if it's within 12 months. So there's some advantages to that. Confirming exposure controls are working is very important. You know, you can assess that, you can conduct sampling, and the biological monitoring. Are the controls you put in place to control lead exposure actually, you know, effective? And that's very important to follow up and make those assessments. Working internationally, some of the challenges include you may have countries that either have a lack of lead awareness or regulatory standards and compliance, or they have them, they just don't really enforce them. So that can be a challenge at times. Also, the availability of qualified analytical labs is can be a challenge, especially working in the Middle East and other Asian countries. You may have to ship the samples outside the country to get them analyzed. I had an experience once where I had to rely on the owner operator. It was a state-ran government or state government controlled refining oil company. And we couldn't ship the samples out. We had to rely on them to provide the analysis of lead content there in their own labs, following a recognized standard. Obviously, the quality control, I had very little control over what went on inside their lab, but sometimes you just, you know, that's what you're stuck with. A couple of not so fun experiences, shipping internationally, air sampling equipment and samples, the sample chain of custody. I had an experience where I'd taken a bunch of samples in Saudi Arabia, and I had to ship them out of country to be analyzed. And in doing so, going through customs, they decided to open the cassettes, the closed filter cassettes. So that pretty much ruined all those samples. So when they got to the lab, some of the end caps on the cassettes were not on them. We tape them on, to keep them for shipping. But they had opened them up. They didn't know what they were, I guess, or wanted to look and see what they were. So we lost those. Another experience I had was, and this was in the, I want to say 2006, 7 era. We had some large modules. These were modules that were going up to oil sands projects in Canada that were built overseas. They were built in another country and shipped over to the U.S. And we found that all the yellow, remember we talked about colors of lead? The yellow handrail on these modules was painted with lead-containing paint. So we had, and when I talk about a module, I'm talking about something that is 100 to 120 feet long, 40 feet wide, and 40 feet high, full of piping, structural steel, sometimes pressure vessels and whatnot. So it's all process-related modules. These have handrails, on platforms and steps and all that built into them, and all the handrails were painted with lead-based paint. So we had to remove all the handrails and blast off all the paint, and basically substitute a non-leaded handrail paint on it. So don't just assume if you're having something fabricated outside the U.S. or outside your country that you want to make sure things are checked, and the safety data sheets, and making sure that the supply chain quality is there when it comes to making sure lead is not present in those coatings. Okay, this is a list of references and resources I use to not only build this, but some good information that I want to share with you guys. I do like, I don't know if you've seen it, the OSHA chemical database. I think that's a great database. I won't go through all these, but I found it very helpful, and they've got a lot of chemicals in there. So that's a list of resources and references you can use to learn more about lead. And now I will open it up to questions, because I think I'm about right at mark.
Thanks, Brian. For our attendees, if you have any questions, please enter those into the Q&A box. And for any panelists, if you have questions, feel free to unmute yourself and ask away.
Hey, Brian, this is Bill Young. I was going to ask you about what's the best way to remove lead-based paint or primers from tanks and piping and things like that with the least amount of contaminating other things. And does the waste all have to be packaged and contained before it can be put in the ground?
So I'll answer that in two parts. Let's talk about the removal of the paint. You're talking large surface areas on these tanks, right? These aren't a room in a house or one run of pipe. These are very large surface areas. And my experience on that is the best way is some of the hydro blasting and vacuum blasting that they have available. They have motorized robotic units that can, it's not a person with a blast hose anymore, just blasting away out the tank shell. They have motorized robotic units that will go up and down the shell and basically remove it in a contained way. So I like those systems. They used to be really slow. They're a lot faster today than they used to be. So I think that to me is the preferred way, because you take the human exposure out of it. The challenge you have is on what you asked in your second question, was around the disposal, right? And what do you do with this material, and does it have to go to a landfill or whatnot? And you have to get it tested to make sure, to ensure, what level of waste stream it needs to go in. But a lot of the owner operators that we worked for, that they're oil companies, gas companies, and we're working for them. They have the means, the methods, and contracts already set up for waste disposal, whether it's hazardous or non-hazardous waste. So it has to be characterized and then classified accordingly and disposed of accordingly. So it depends is the question on how it's characterized.
Very good. So yeah, water, and it could be filtered or cleaned also.
That's right.
I'm assuming, so you can recover that, and it doesn't.
And all you have is a pasty sludge at the end, right? You let it dry out, and it almost turns back to paint chips.
Okay.
Or powder.
Very good. I don't see any other questions right now. Do you, Michelle?
I do not.
So, all right.
Okay.
Well, I appreciate
Thank
your
you.
time a whole lot. Very good. Very good.
Thank you very much, everyone. Have a great day.
Thank you, Brian.
Mm-hmm.
All right, everyone, we are back from lunch. Thank you for joining us again. For the rest of the day, we will keep rolling with one more break in between after the next two presenters, and we'll finish out our day at 3:00 p.m. So first off, to kick us off for our after lunch session is Mr. Freddie Polanco, President of Professional Environmental Training, on presenting on regulations and resources to lessen lead risk in the environment. And Mr. Polanco is the owner of Professional Environmental Training and has been in the safety, industrial hygiene, and environmental industry for over 30 years. He started with UT Health Tyler as the director of the O&E training program and was a faculty member of the Occupational and Environmental Medicine program there. So, Mr. Polanco, thank you again for joining us today, and I am going to go ahead and turn it over to you to start.
Okay, thank you very much. I'm going to do a quick review of some of the lead regulations. Not all the regulations are associated with paint, but that's basically the main base of a lot of the regulatory requirements, especially of the pass of Title 10. But I'm going to start doing a review. Lead, again, we already know that it's in our environment, right? It has been used for many years. Yearly record lead mines in Turkey about 6,500 before Christ. Also, lead was blamed for the decline of the Roman Empire because of the lead in the water supply. Properties of lead, that's what makes lead a good material for industry. Soft metal, easily low melting point, easily recyclable, inexpensive, high density. That's what we see in our vest, block the radiation. That's what we see that in our dentist office. So these are the good properties of this material. Now, lead is also a poison for any living organism, right? In the human body, is going to be absorbed to the bloodstream, and is going to be stored mainly on soft tissue and also tissue that is rich in calcium. That's because lead in our body apparently is confused with calcium. So majority of lead is going to be stored in bones and teeth. About 95% of the lead that is absorbed is going to be stored in bones and teeth. Only 5% is going to be excreted. This is some numbers from the city control. How blood lead levels have been lowered of the time that was considered to be elevated blood lead level. For example, between 16 and 70 was 60 micrograms per deciliter. In the 70 to 85, it was 30. 85 to 91, actually, when we start talking about the HOT regulations and the housing regulation was about 10. That was reduced to 10 micrograms per. That was basically the CDC intervention level. So between 10 to 14 was the intervention level. That means we have to do a little more look of a child that come out with this level. The CDC also have levels at that point for adults about 25, right? 25 for adults, children 10 intervention level. And presently, that has been reduced to 5 micrograms per deciliter, not only for children, but also for adults, right? You have the reference in the bottom of my slide, the CDC, that was in 2012, not only for, again, not only for children, but also for adults. That's the present intervention level. Now, talking about the EPA, the Residential Lead-Based Paint Hazard Reduction Act of 1992, what's called a Title 10. With the requirements for lead-based paint activities in target housing and child occupied facility. Target housing is under this Title 10 is any house pre-78, okay? Doesn't have to, that's what it's called target housing. Child occupied facility is also pre-78. And the reason that we talk about 78 is because the Consumer Product Safety Commission banned or reduced or banned lead with a percentage greater than 0.6% or 300 parts per million in 1977. So that's what we call a target housing or child occupied facility that requires any kind of activities, right, on those facilities to be regulated. Including accreditation or licensing in some states for entities or individuals doing lead-based paint. Under this title, elevated blood level on a child means a confirmed concentration of lead in the whole blood of 20 micrograms per deciliter for a single venous test, or 15 to 19 micrograms per deciliter in 2 consecutive tests, taken 3 to 4 months apart. This is also again part of the Texas lead reduction rules that were published in 1996, because Texas became an authorized state for enforcement of the EPA manual accreditation plan. The people that do the investigation of elevated blood level, that's one of the procedures under Title 10, was an investigation of elevated blood level to be done by a state or an accredited certified risk assessor. Occupational exposure, right? Again, we're talking about elevated. This is for children. In occupational exposure, we have basically two regulatory numbers under the point of view of blood testing, right? We have the general industry standard, 1910-1025, that was published in 1978, and the construction industry standard that was published in 1993 under the authority of Title 10. Because we were looking at housing, right? The houses were, but who was going to do the remediation of those houses as far as lead-based paint? We did not have a construction industry standard. So the construction industry standard was published under the authority of Title 10. We have initial medical surveillance, which includes, right, any kind of operation in which an employee might be exposed at any time during the year about the action level. Now, if that exposure, right, after we do the exposure assessment for those activities, if the exposure is going to be more about the action level for 30 or more days per year on 12 consecutive months, then again, the employees are subject to the medical surveillance program. They require employees to have a blood level below 40 micrograms, right? 40 micrograms, actually OSHA has received a lot of criticism about those high levels, 40 micrograms per deciliter or 40 micrograms per 100 grams. That's the general industry. The 40 micrograms per deciliter is the construction industry standard. So any employee of any time that is part of the blood testing, any time that gets above 40, right, above 40, the employee has to be notified of that if that level exceeds 50 micrograms per deciliter, he or she are going to be subject to what is called the removal benefits, which means the person at 50 micrograms per deciliter is going to be removed from the job site. So if it's above 40, it's going to receive the notification. And we go in construction, that blood testing is going to increase the frequency. from every 2 months, from every 6 months to every 2 months, right? Again, we are talking about people that are exposed about the action level for more than 30 days a year, okay? So the exposure assessment in these kind of jobs are very important because that's going to determine the frequency or if any more blood testing has to be performed as part of the medical surveillance program. Now for under Title 10, again, we are talking about under the construction and general industry, we have what is called a removal. An employee that gets at or about 50 micrograms per deciliter of any time a blood test is performed as part of the medical surveillance program, the person has to be temporarily removed due to elevated blood level. And that person is to return if that person was removed because of a high blood level above 50, that person is going to return when 2 consecutive blood levels taken every month is going to be below 40. So somebody removed 1 week is going to be a confirmation of that high blood level, and every month, right, that person is going to be subject to a blood test. Now the benefits, or just is 18 months. So the person is going to be removed from the exposure to lead, not necessarily to go home, but the exposure to lead up to 18 months. Every month, again, that person is supposed to maintain his job status, his pay, and all those things, benefits of it being employed, okay? Requirement for medical examination and consultation, if we have at least annually for each employee, the blood level gets above 40, at or above 40. So that is going to be subject to a medical examination and consultation. An employee can be removed not only because of high blood level, but can be removed by a doctor due to the employee showing any symptoms. And in the opinion of the doctor, that person has to be separate from lead exposure. Some jobs that we mentioned here that are, again, part of the construction and general industry standard, abrasive blasting construction, right, lead burning, any of these operations, again, they can be part of construction and general industry. This is construction, demolition, removal, new construction that basically has to do with, again, with the construction. And this is the activities that are regulated by OSHA, okay, by OSHA. Under OSHA, by the way, as we're going to see it under the other agencies, lead-based paint, for example, is any paint that has any lead. So if that's one of the problems sometimes that we have with industrial facilities where they are, concerned because the air sample or the paint chip samples can be low. What we use for housing under Title 10, which is 0.5% or 1 milligram per centimeter square, and they are below that stuff, and they want to call it non-lead-based paint. Under OSHA, right, for water protection, that is still the amount of lead in the paint can be enough to generate dust above the permissible levels. Exposure assessment regulated by the general industry, by the construction industry, under 62, that's the construction industry standard, paragraph C. Okay, that is the exposure assessment in a construction job. That we have a concern about exposure to lead is going to be the first step to be taken, because based on the results, we're going to do other things like provide respiratory protection, and based on how high is the exposure, we determine what type of respiratory protection has to be provided. Protecting clothing, medical surveillance, frequency of blood testing, right? So if the exposure is below, the exposure assessed below the action level, right, which is 30 micrograms per cubic meter, we don't have to do more blood testing for that specific operation. This is the levels under the construction industry standard, right? The air level is 30, the action level, 8-hour TWA, and the permissible level is 50 for an 8-hour TWA. Under this standard, under the construction industry standard, the permissible level can be based also in the number of hours. So if we work 10 hours, right? So 400 divided by 10, that's going to be the allowable exposure to the employees before all these other requirements will apply, including respiratory protection. To determine if a paint has lead or not, we can use, again, there is an equipment called an XRF. basically use a radioactive source, and it's going to give us the concentration of lead in the paint in milligrams per square centimeter, okay, for a square centimeter. This equipment uses a couple of sources, cobalt 57 or cadmium 109. Those XRFs were required to be tested by under the authority of Title 10 by the EPA and HUD. So any of those machines that are going to be used in housing, they have to have what is called a PCS, a performance characteristic sheet. I compare that with a consumer report. That means it's going to be HUD and it's going to be the EPA based on their work. They are going to tell us how accurate, whether or not the machine is going to read concentrations as low as 1 or greater, or it's going to tell us if that machine requires substrate correction. So in other words, there are some machines that the reading that we get for some of the substrates has to be corrected for what is underneath of the paint. So there is a specific procedure, again, the use of these machines. That's how we determine, again, in housing, if we have lead in paint or not, okay? This is basically the protocol under chapter number 7 of the HUD guidelines. Sometimes some of my clients call and say, hey, Freddie, can I do a lead inspection if I don't have an XRF? Well, you can do an XRF, but I bet you can do an inspection, but you better be sure that your client is going to allow you to collect a spray paint all over the house, and that's going to be very unlikely, okay? So this is the destructive sampling, paint chips, right? We use mostly this in industrial facilities when we're going to clean or paint or repaint a tank or any kind of structure. So we're going to collect a paint chip sample. It's going to be analyzed by atomic absorption spectrometry, right? And basically the report is going to be either in percentage by weight or parts per million by weight, right? Generally speaking, unless we measure the paint chip, we're going to get this by weight, okay? Parts per million or percentage by weight. Okay, by the way, under the HUD guidelines or HUD regulations, lead-based paint is 0.5% or 5,000 parts per million by weight or by area, where the XRF machine is 1 milligram per centimeter square. Air monitoring, again, part of the exposure assessment under OSHA. We can use what is called the NAS 7082 method. Okay, that is specified, right? If we're going to use, like any time that we sample for dust, we're going to use a pump, a low volume pump, the tubing that connect that with the cassette, so about 37 millimeter cassette. Mixed cellulose ester is going to be the filter that is going to be collecting the lead dust that is coming through the sampler. Obviously, the person that is collecting, doing the exposure assessment, is going to determine the flow rate, right? The flow rate, the time, so they can get the volume reported to the lab. So the laboratory will weight the amount of lead, and is going to report, those things in the. All right. Okay. Lee. So now under the OSHA standard, we have some. Excuse me, just a minute. Lee, would you just hang out with that person? I cannot. What is that? Give me the feedback, kind of stuff. All right. Protection of the employees and during the exposure assessment. And the paragraph B.
Mr. Polanco, I think we lost your audio. Can you say something?
Hello.
Oh, there you are. Okay.
Okay, I'm sorry.
It's okay.
I'm sorry. So under OSHA, before we get the exposure assessment to determine what respiratory protection, what hygiene facilities we have to use, we're going to have to protect the employees until we get the results of the exposure assessment. So that's what is called protection during the exposure assessment. So we're going to select the respiratory protection, right? We're going to select the respiratory protection based on the task, right? Under OSHA, based on the type of job that is being performed. So for example, if we're going to do abrasive blasting, right, we're going to have to use an air supply respiratory protection because we are assuming that when we do this kind of task, the exposure will be about 2,500 micrograms per cubic meter. Okay. Now, if generating thicker or bigger particles. So only half face or half mask respiratory protection will be required with the P100 filters, right? Because again, we are assuming until we get the result of the exposure assessment that we're going to be above the PL, which is 50 over 8 hours, and it's going to be up to 500, which require the use of half face air purifying respirator. Again, this protection is before we get the results of the air sample, okay, of the exposure assessment. Whenever an exposure is likely to exceed the PL, again, protecting clothing, this is another level of protection. We have to protect clothing, we have to have change areas, we have hand washing facilities, and again, we have to do an initial biological monitoring. Even, again, before we need to protect employees under the OSHA standard before we get the results of the exposure assessment. The respiratory protection is going to be based on the task. We have to provide protecting clothing, change areas, hand washing facilities, and biological monitoring. Okay, that's going to be part of the initial medical surveillance. Okay, we also have required to do the training according to the OSHA standard, which is different from the training requirements for employees under Title 10. This is, again, OSHA requirements in 1926-62. How frequent are we required to do an exposure assessment? Again, if the initial exposure assessment is said that we have at or about the actual level, but below the PL, we are required to do another exposure assessment every 6 months. If the exposure is above the PL, every 3 months. Every 3 months. And if the exposure is below the actual level, we don't have to do an exposure assessment for that task. So below the actual level, we don't have to do more exposure assessment for that task. Above the actual level, below the PL, is going to be every 6 months. And if it's above the permissible level, which for 8 hours is 50 micrograms per cubic meter, it will be every 3 months. Okay? Now, whenever if we have an exposure assessment for a specific job, but we're going to change equipment, process, control, even personnel, or we're going to have a new task, again, we're going to have to do a new exposure assessment, right? We have to do exposure assessment because we are changing the conditions for which we obtain the exposure assessment. Other provisions under OSHA, okay? Engineering controls, ventilation for some blasting operations, is going to be personal protective equipment, housekeeping, hygiene facilities. For example, if the exposure assessment is below the PL, then we have to have a shower, part of the hygiene facilities and practices. Medical surveillance, again, is going to be assessed based on the exposure assessment. If it's more than the actual level, more than 30 days a year, we have to be part of the medical surveillance program. Employee information and training has to be annual for anybody exposed above the actual level as well, okay? And again, record keeping and other provisions under that standard. Now, this will take us to the Residential Lead-Based Paint Hazard Reduction Act that we have heard before. That is what we call it the HAZ regulation, but it's not necessarily housing and urban development regulation. That's also some guidelines for non-public housing. So in other words, this piece of legislation, this act, basically changed a lot of the things that we do in housing, including property owners, right? Because now, if I'm going to sell my house and my house was built before 1978, I'm required to notify the potential buyer, right? Before he's committed to by contract, I'm going to have to notify him and give it some 10 days to decide whether or not to buy my house due to lead. I have to notify that my house was built before 1978. And it might have lead-based paint or lead-based paint hazard. That also applies to landlords, lenders, right? Some insurance requirements address the issue of lead, and of course, contractors removing lead-based paint, they're going to have to be licensed in different states. People that do the inspection, so basically, Title 10 was an effort to put all these agencies together: worker protection, OSHA, the Housing and Urban Development, and the EPA, to minimize the lead poisoning on children, on housing. levels of lead-based paint, what we call it abatable surfaces or lead-based paint for housing, 1 milligram per square centimeter or greater. By weight, again, milligrams per square centimeter is what the XRF report the concentration of lead. Our 0.5% by weight, 0.5% is equal to 5,000 parts per million. That's by weight. The inspection is going to what? The inspection is going to, if I do an lead inspection, I'm going to report to my client, do you have whether or not you have lead-based paint and where is it? That's what we call an inspection under Title 10. Lead-based paint hazard we're looking for hazards associated with lead paint due to contaminated dust, and there are some levels that we define contaminated dust, contaminated soil, and what we call in deteriorated paint that is in poor condition. So when we do a risk assessment, we're looking for lead-based paint hazard. When we do an inspection, we're looking for lead-based paint, okay? Lead-based paint hazard is the one that generates the contaminated dust, contaminated soil, or deteriorated paint, okay? This is what the exclusion from target housing, right? Target housing is any house pre-78, except, for example, studios. I guess they are exempt from the definition of a target housing because I guess kids do not expect to live in those types of apartments. A child occupied facility is basically can be a hospital that have the same child being there for twice a week, right? 3 hours a visit, 6 hours a week, or 60 hours per year. Daycare facilities, preschools can be child occupied facility. And basically what that happening here, if they're going to do a renovation job in one of those facilities, and we're going to do some kind of disturbance of the paint because of the renovation, and we're going to do an inspection, has to be done by an accredited or a licensed inspector in that state for lead to do lead inspection. The same for the people that are going to do risk assessment, or the contractor that is going to remove the lead-based paint is going to have to be licensed or accredited or comply with the requirements under Title 10. Removal of measures designed to permanently eliminate the hazard, that's what we call lead abatement. Lead abatement is not only a removal of lead-based paint, can be also an enclosure, which is basically a hard surface that is going to be placed to cover the lead-based paint, mechanically fastened, where encapsulation is the application of a liquid that has been certified to, under normal conditions, to last 20 years and to comply with an ASTM standard to be certified to last 20 years. This is the disciplines that are going to be that we have under the accreditation in Texas. The Texas Department of Field Services is the one that is in charge of the accreditation under Title 10, under the EPA Model Accreditation Plan. Lead inspectors are going to report the presence or the absence of lead-based paint in target housing or child occupied facility. Lead risk assessor is going to determine lead-based paint hazards. Lead abatement supervisors are individuals working for contractors, right? They supervise asbestos and lead abatement workers. And lead abatement project designers, the people that basically design the projects, right? Design what is called occupant protection plan or project design. We're going to design the project so we don't spread the contamination to other parts of the house or the multifamily. Lead abatement workers, lead firm. So all these disciplines in the state of Texas they call it accredited, which I call it licensed because we have to pay money. Okay, and that accreditation in Texas has to be updated every 2 years. Every one of those individuals are going to take a class from an accredited lead training provider. Accredited by who? By the state, by Texas Department of Field Services. Okay, inspection. That's what I was talking about. Inspections. We're basically going to locate the paint and we're going to document it in a report where is in the individual house or a multifamily. We also under this Title 10, we also have a protocol how to do inspections of multifamily. A multifamily is defined as a set of properties or a set of dwellings that have the same paint history based on construction date and they have been under the same management. So those multifamily, if the multifamily was built in before 1960, the multifamily protocol can be used if we have more than 21 units or more. If that multifamily was built before 60 to 77, that's going to be 10 units or more. So that's the definition of multifamily, and we normally do a representative samples of sanitary units to basically address lead-based paint for the whole complex. Risk assessment done by a certified risk assessor. We're looking for lead-based paint hazards, right? So we're going to do a lot of dust sampling. We're going to collect dust samples when we think a child can be exposed. Soil samples, we take 2 composite samples of the soil, one in the drip line and one for the rest of the yard. Again, and all those numbers all those samples are going to have a point of reference. We're going to talk about it in a couple of seconds here. This is the numbers that I was talking about. This is under HUD, right? Residential property, right? Lead-based paint hazards, right? For floors, 10. For interior window seals is 100. Exterior window seal is 100 micrograms per square foot. That is for under HUD. Now the EPA, the ones again that was recently updated for clearance, right? And for clearance and also for assessment. This is standard. These numbers are coming into effect or are going to be enforceable next January, right? Again, the EPA already have changed those numbers. The Texas Department of Field Services, which is the agency that enforces these those operations, they update the rule to become in line with the EPA, and that's going to be again coming in effect next January. We also have other procedures that are called lead screen, right? Which is a quick. That's what it's called, a lead screen, right? It used to have more stringent requirements than the regular. I'm going to give you an example. That has now been updated. When we did a risk assessment, the maximum concentration of lead that we can have in floors used to be 40, as you can see in the slide, right? 40. For the lead screen, we take composite samples of the floor, and it was supposed to be 25. So they have more stringent requirement for passing. So to do a lead screen, that's what we call a quick. I would call it a quick high liability type of assessment, because you're not going to sample soil, you're not going to look at the history of the property. So it's going to be based on a composite sampling, very quick composite sample of dust on floors, dust on window seals, and we're looking for deteriorated paint or chewable areas that might be subject to be chewed by a child, right? So that's, again, that's a quick look at the hazard of lead-based paint in a property. Risk assessor, that certified risk assessor is the one that is going to be, that's another activity under Title 10, elevated blood level investigation, to be done by a certified risk assessor. And in this case, we're not only going to do an inspection or risk assessment, we are going to look for a possible source of the poison of a child. We're going to look at glazed pottery, we're going to look in home remedies, we're going to test the water, we're going to probably do more soil testing, not only in the house, but also where the child normally goes. In other words, this is not going to be restricted only to the property where the child lives. Is going to be a complete investigation about where the kid was exposed to lead. This is the requirement for a BAME, and when we do it, removal of lead-based paint in target housing or child occupied facility, to be done by certified workers, certified by who? By the state under the EPA manual accreditation plan. We are required to file a notification that might trigger an inspection to the job. Okay? We're going to have a written occupant protection plan. It's like the specifications. We're going to specify how we're going to protect the occupants from getting exposed to lead, releasing that from the job site. We're going to have a post-abatement clearance. So we're going to have a third party, right? The contractor, the facility owner will have a third party that is going to take dust samples on the soil, on the floors, and on the window seals of the areas that are being treated, right? And also we're going to dispose the waste properly. Now, initially under Title 10, and we're going to discuss that when we talk about disposal. Initially, the waste, lead-based paint waste that was generated by lead abatement jobs in target housing or child occupied facility was subject to the regulation calculations. In other words, we were doing the TCLP to determine if the waste was going to be disposed as a hazardous waste or non-hazardous waste. That provision was changed, right, in 2003, in which the EPA reclassified the waste of lead, right, into household waste. This is the HOT guidelines. These are the HOT guidelines, different chapters. Chapter number 7 is the inspection protocol. Chapter number 5 is the risk assessment protocol. And then we are talking about other chapters that address clearance, how we do clearance, right? How we do encapsulation, abatement, all those things, and how we do an EBL investigation, some kind of guidance. This is what is called the HOT guidelines. Again, they were created by HUD under the authority of Title 10, or the requirement of Title 10. Again, I was talking about the waste. Again, waste, lead-based paint waste can be hazardous. I was telling you that in 2003, for housing, the EPA basically reclassified the waste into residential waste, right? Basically taking the requirements of a RCRA out of that waste. However, I know that there are some regions in the country that still wants housing waste to be subject, lead-based paint housing waste to be subject, if it's done by a contractor, to be subject to the RCRA requirements. This is the requirement for disclosure. That's under Title 10 again, in which we are required to disclose, right, the presence of lead-based paint or the possible presence of lead-based paint hazard associated with housing pre-78. Okay. So that disclosure covers sellers, right, people that do lease their property, right, and again, we have to give the potential seller or buyer 10 days opportunity to do a risk assessment or inspection before he's obligated under any purchase contract. Okay. Real estate people see that as a deal breaker, because that can cause a deal to break, especially when the potential buyer is knowledgeable about this subject and have little kids. Okay. Real estate agents need to be aware of these requirements to provide to the potential buyers. This is the different subparts under HUD. This is the housing and urban development, right? The housing development, we have this is for public housing. These are the different programs under public housing. Okay, they also disclose rehabilitation. Okay, there are different. Now this is the requirement that applies to paint. Again, the Consumer Product Safety Commission banned the use of lead in paint above or equal or above 0.06% of 100 parts per million by dry weight, right? Since 2009, that number has been reduced. Right now, it's 90 parts per million, okay? By the way, some kind of historical number. In 1955, the White House have a paint that contains 50% lead. Remember, lead in paint used to be viewed as a good quality paint, right? The more lead was in paint because it was going to be more durable, it was heavier, subject to, more resistant to humidity, many of the other things, corrosion control. So it was seen as a good. Now, in 71, it was reduced to 1%, right? And in 1977, the Consumer Product Safety Commission reduced for commercial paint. Keep in mind that still some industrial paints might contain lead about those. This is for commercial and residential paint. In soil, we also have some levels of concern for target housing and child occupied facility under Title 10. 400 for plain areas and 1,200 for non-plain areas. Okay, that's again the number that was established by Title 10 for soil. Okay, so when we're doing a risk assessment, right, we're going to collect samples of the drip line, right, and we're going to compare. If we think the drip line is a plain area, which I personally think any part of the yard is going to be a plain area, I'm going to compare that with 400. Okay. Drinking water, there are some action levels. Basically, the two levels of protection are the action level, 15 parts per billion, okay, of lead, or 1.3 parts per million in copper, right? In copper, and the maximum contamination level the goal to be zero. Again, that was the other level of protection. Those two. The EPA, of course, under the Safe Drinking Water Act of 1991, set up something of drinking water throughout the country. And mostly of the whole country, these levels were below 15 parts. We have some levels in some areas of the country, but was mostly for the piping of the house, the solder that was in the piping of the house. Okay. Some of the levels that we need to look here in 1988, the EPA, right? The EPA basically banned the use of solder, lead solder, in drinking water. Other standards, again, we talk about food, the Food and Drug Administration, right? The Food and Drug Administration, we have set up numbered action levels that are enforceable, and those levels of concern of lead various food, right? For example, the Food and Drug Administration has set an action level of 0.5 micrograms per deciliter for lead in food products intended for use by infants and children, and banned the use of lead solder in food cans back in 1994. Okay. 2018, the Food and Drug Administration reduced the maximum allowed daily intake, right, of lead for children from 6 to 3, and adults down to 12.5 micrograms per day for adults. So it's not only pain. We also have it, as we saw it in drinking water, soil, right? Soil, other kind of. Now, somebody was asking me earlier today if we have other levels, you know, for dust and soil and so on and so forth, upside housing. The only standard that I know that exists up there is going to be under the ASTM. ASTM, again, is the American Standard for Testing Materials, and they have some protocols about testing lead-based paint upside housing. And also they have established some kind of, they are not regulatory levels, but they're guidance levels for non-housing, okay? The Consumer Product, the American Standard of Testing Material, ASTM, okay? The primary and secondary lead standards are, again, this is for air, right? Under the Clean Air Act, under the National Ambient Air Quality Standard, 0.15 micrograms per cubic meter as an average of 3 months, right? 3 month readings. And also, the Clean Air Act regulates lead under niche of the National Emission Standard for a specific source, right? For a specific industrial source. This is some reference when I basically come to this, obtain all these materials. We're talking about, you know, the general industry, 1025, that was published in 1978. Title 10, 1992, that was signed into law by President Bush, Senior Bush, with the effort to protect children from, I mean, they were trying to put the efforts together. All these regulatory agencies, they were doing the work separately. In other words, we didn't have an act that was putting together an effort to reduce the lead poisoning around the country. I tell you what, in my view, and for the training that I do here in my facility, lead to me in construction is a bigger problem than the other contaminants that we have that are more regulated. Okay, we have seen again, because the only focus of lead as far as occupational exposure, besides industrial facilities, are a contractor working in housing, and because they are required by the housing authorities to take precautions and to use the appropriate work practice and procedures, to be trained, and so on and so forth. The Texas Environmental Lead Reduction Rules, they were published basically to address the requirements for entities or individuals doing lead-based paint activities in target housing and child occupied facilities. Basically, it's a copy of the EPA Model Accreditation Plan. It's being amended, right? The only amendment that I can see, the only changes to the new rule that is going to come into effect in January is just the clearance levels, right? The clearance levels, and also the risk assessment levels. 10 for floors, 100. 10 for floors, 100 for window seals, right? Where before there were 40 and 250. The Consumer Product Safety Commission, TSCA, right? TSCA, which is these sections of TSCA are part of Title 10, right? The mandate from Title 10. And again, we have also other agency, the National Ambient Air Quality Standards, all the reference that I got for this presentation. I think I'm finished. Anybody has any question? And I basically finished, I thought it was going to be almost impossible, but I finished 1 minute before my due time.
Well, there you go. Thank you for that. So for our attendees, if you have any questions, please enter those in the Q&A box, and Bill will moderate those to Mr. Polanco. And then any of our panelists, if you have questions, feel free to unmute yourself, turn on your video if you would like, and ask your questions. We'll take a few minutes.
That will be fine.
Get back to work, Freddie.
Yeah, I need to do that.
Very good. Very good. Appreciate it.
Thank you. Thank you, Bill.
Yeah, Freddie, I know you have a course you're teaching, so if you'd like, we'll release you. Thank you for your presentation today. Thank you for your service, and we'll send you the recording next week when we're done, so you can have this.
Yeah, thank you very much for having me, and again, there's a lot of things to cover. Bill reviewed my presentation, and he thought they have too many slides, and I was trying to cut some, but I thought I just want to try to be as fast as I can so I can get them all done.
Yeah, it's important information, so thank you.
You
Thank
made
you
it.
very much. Thank you very much.
Very good.
Bye-bye.
Thank you.
Thank you. All right. Okay, and in the meantime, I'm going to introduce you quickly before I pass this off to you. So thank you again for joining us today, and thank you for your service and presenting here with us. For our audience, Mr. Bernard Fontaine is the managing partner at Windsor Consulting Group Incorporated, and he has over 45 years experience in regulatory compliance, national defense, insurance, and consulting. Currently, he is a member of the AIHA Board of Directors and will be presenting on occupational health hazards of leaded gasoline used in the transportation industry. So, Mr. Fontaine, you can take it away.
Thank you, Michelle, and thank you, Bill, for allowing me to present today. This presentation covers not only the discovery and use of tetraethyl lead in gasoline, but the toxicological effects that have occurred over the last century. For most of the mid-20th century, leaded gas was considered normal. But as we all know, lead is a poison, and burning it has dire consequences. Both tetraethyl and tetramethyl lead, called lead alkyls, was not manufactured for any other use or purpose other than a gasoline additive. Leaded gasoline has been banned in the United States since 1996, but less than 20 years ago, 117 countries still use leaded gas. Many nations in the sub-Saharan Africa and other low-income countries rely on the fuel, which can cause a suite of health problems throughout the entire body. According to CDC, the fuel is linked to causing health issues from heart disease, high blood pressure, strokes, kidney disease, and reduced fertility. The chemical also easily pollutes the air, soil, and water, according to EPA. The United Nations formed a coalition called the Partnership for Clean Fuels and Vehicles in 2002 to rid the world of leaded gasoline. The group campaigns to spur consumers to pay more safer effect to pricier unleaded fuels, according to several sources. The good news is that the last leaded fuel, as indicated in a couple presentations, has finally disappeared from gas stations. By 2016, only Algeria, Yemen, and Iraq were the holdouts. The United Nations Environmental Program estimates that this action prevents 1.2 million premature deaths, avoided health costs, and regained human potential that could be worth nearly $4.2 trillion annually. The bad news is that leaded fuels are still being used in aviation, motorsports, agriculture, and off-road uses. For most of the 20th century, leaded gas was considered normal. but it really wasn't. Lead is a poison and burning it had dire consequences, as I said. But this whole issue of tetraethyl lead goes back to 1921, when General Motors engineer named Thomas Migley and his boss, Charles Kettering, discovered a new additive which worked to reduce knocking in car engines, as well as prevent an engine exhaust valve and valve seat wear. This additive, tetraethyl lead, called TEL, was a highly toxic compound that was eventually discovered back in 1854. The discovery continued to have impact far-reaching beyond car owners. Back in 1916, Dayton Electric Light Company, the president, Charles Kettering, asked researcher Tom Megley to begin working on a problem of engine knock for the Delco electric generators that were being produced. Megley discovered that iodine has an anti-knock compound, but it was very too expensive to use. So Megley, who was not a chemical engineer, but actually a mechanical engineer, began working on the process. By 1917, Kettering and Megley tested a bunch of fuels, even for the Army Corps at Wright Air Force Field. They used alcohols and benzene as the best anti-knock substances that they considered available, but it was unsuitable for aircraft engines except in blends with gasoline. 1918, Kettering and Megley manufactured cyclohexane from benzene. As the war ended, produced the engine knock. But in 1919, Megley discovers that aniline seems to be the anti-knock additive that appeared to be the best for the Detroit GM headquarters cars. But aniline is expensive, dangerous, and foul-smelling. By 1921, anti-knock research almost was abandoned, but Megley continued to research this. He looked at selenium and tellurium as other additive agents. He also demonstrated at that time that 30% ethyl alcohol blended in gasoline was a good anti-knock, and this was presented at the Indiana Society of Automotive Engineers. But this was abandoned. By 1922, he continued his tests and worked with tetraethyl lead. The valve, spark, and exhaust failures were still problems, but scavenging fuels like ethylene dibromide were seen to be another alternative. But there were strong letters of concern about the safety of tetraethyl lead by fellow scientists and the Public Health Service to General Motors. They looked at first demonstrations of tetraethyl lead on engine knock, and it was presented at the American Chemical Society convention. By 1923, Megley took a few months off to recuperate because he had, personally, lead exposure. The first commercial sale of tetraethyl lead was by the Ethyl Gasoline Corporation in Dayton, Ohio. GM produces a line of automobiles to incorporate tetraethyl lead, but no health tests had been conducted at this time. In 1924, when tetraethyl lead was being produced, we find that 2 workers died because of exposure to tetraethyl lead. In DuPont factory, in Deepwater, New Jersey, across the Wilmington Bay here, first worker who died was from poisoning. The second one was a janitor who died from lead poisoning in the TEL process. Apparently, the TEL was on the floor and it absorbed through his boots. This continued on to 1924. The DuPont engineers voiced grave concern of the safety of the semi-works of the Bayway refinery. Concerns were brushed aside. 6 Standard Oil refinery workers died violently insane following daily exposure to tetraethyl lead vapors at the Bayway ethyl plant. Additional 33 workers are hospitalized. Some of these people will spend the rest of their lives at the Greystone Psychiatric Hospital from 1932 on, and then later at the Marlborough Psychiatric Hospital in New Jersey. He and other workers will spend the next 40 years in psychiatric institutions due to nerve damage. The family members are devastated. In 1925, criminal charges were dropped against Standard Oil by New Jersey grand jury investigating the deaths and injuries. 3 more workers died at the DuPont ethyl plant in Deepwater. There was the last worker to die at Deepwater before it closed down in 1925, but Yale University public health scientists claimed that ethyl gasoline represents the greatest single question in the field of public health which has never been faced by the American public. Public Health Service studied 225 drivers and auto mechanics in Dayton and Cincinnati, Ohio. Researchers find that drivers exposed to leaded gasoline showed somewhat higher stippling damage to red blood cells, while garage workers exposed to leaded gasoline showed much more damage to the red blood cells themselves. 1/4 of the garage workers had over 1 milligram of lead in their fecal samples. In a published report in 1927, the Surgeon General Committee said that blood cell stippling was found to have a regular high degree in garage mechanics whose exposure had been relatively short, even as short as 2.5 days. By 1927, despite all these warnings, Surgeon General set a voluntary standard of lead content, which the refining industry successfully met for decades. It wasn't until 1960s, following extensive health research, that the devastating health impacts of low-level lead exposure was established. While we're talking mainly about tetraethyl lead, for use as an anti-knock compound in leaded gasoline, tetramethyl lead, TML, was introduced for the same purpose in 1960. The two chemicals were added singularly or together as mixtures to achieve the desired octane numbers. Higher lead levels in the urban environment have been attributed to extensive use of leaded gasoline in automobiles for over the last 50 years. While the degradation pathways of TEL in soil are unknown, both TEL and TML could be detected in soil on urban roadways. Microorganisms in soil have not been found to degrade TEL or TML. In 1970, emissions from cars and trucks were one of the largest sources of lead in the United States. Congress passed the Clean Air Act in 1970, setting in motion the formation of EPA and ultimately the removal of lead from gasoline. By 1975, unleaded fuel was phased in as a replacement for leaded fuel. EPA estimates that between 1927 and 1987, 68 million children were exposed to toxic lead levels from leaded gasoline alone. The phase out of lead from gasoline subsequently reduced by the number of children with toxic lead levels in their blood by 2 million between 1970 and 1987. While new cars are no longer guzzling away leaded gasoline, the aviation industry still uses avgas, a type of fuel which contains lead. According to certain sources, the shift away from leaded gas has created a greater reliance on diesel, another fuel that can be hazardous to the environment and human health. In 1995, leaded fuel was accounted for only 0.6% of all total gasoline sales. From 1996, the U.S. Clean Air Act banned the sale of leaded fuel for use on on-road vehicles, although that year the EPA indicated that TL still could be used in aircraft, racing cars, farm equipment, and maritime industry. Thus, what had begun in the United as a phase down ultimately ended up in a phase out for on-road vehicles. Leaded fuel was commonly used in professional motor racing until its phase out began in the 1990s. Since 1993, Formula One racing cars are required to use fuel containing no more than 5 milligrams per liter of lead. NASCAR began experimenting in 1998 with an unleaded fuel, and in 2006 began switching the National Series to unleaded fuel. This was influenced after blood tests of NASCAR teams revealed that elevated blood lead levels. Similar bans in other countries have resulted in lowering levels of lead in people's bloodstream. In 1996, with the cooperation of USAID, Egypt took almost all of the lead out of its gasoline. That success in the model began a worldwide effort. By 2000, TEL industry had moved the major portion of their sales from developing countries to those governments who lobbied against phasing out leaded gasoline. Leaded gasoline was withdrawn entirely from the European Union market in January 2000. Finally, India also joined the ban in March. Over 90% of the lead released from the combustion of leaded gasoline in vehicles was in the form of lead halides, called lead bromochloride, while 10% it was in the form of lead alkyls, tetraethyl or tetramethyl lead. Tetraalkyl lead compounds once accounted for 5 to 10% of lead emissions in the atmosphere, according to the National Toxicological Program on Carcinogens, 14th edition. Lead and lead compounds are reasonably anticipated to be human carcinogens based upon limited evidence of carcinogenicity from studies in humans and sufficient evidence of carcinogenicity from studies in experimental animals. In 1991, July 25th, ABC did a primetime expose I would call the hidden poison, and it had a number of broadcasts on talking about the exposure of lead in soil from the urban use of automobiles over the number of years. And what they basically found is that construction workers and anyone who doing roadway work were exposed to lead from the emissions from the vehicles from all those years. And that led to one of our cases that was very important, where they were actually remediating the shops underneath the Queensboro Bridge. This happened in the early 1990s. And they buttoned up the underneath of the bridge to do the remediation so they weren't affected by the neighbors and they wouldn't, have noise and everything else. But what they did is when they put all the plywood up to secure the underneath of the bridge where these shops were going to be put in place, they didn't use any exhaust ventilation. The job was to basically jackhammer the concrete floor and to remove it so they can put another floor in. What they didn't know at the time was the fact that lead from all the traffic that crossed the bridge over all these years was in the soil itself. So when they jackhammered the concrete floor, break it all up, they generated tremendous amounts of dust in the air. So without respirators or any personal protective equipment or anything else we've been talking about regarding OSHA requirement for lead exposure, these persons were exposed very high lead levels to the point that medically they were considered poisoned. And they were so far poisoned that they could no longer be returned to work. And then it became a lead lawsuit against the employer for not knowing, and also the architect of the project for not knowing that lead may be in the soil. We've seen other cases similar to this, where we have children who are exposed to lead at relatively high lead levels, and they're living in an apartment complex, a public housing complex, and they are removed from that public housing complex and put into a safe zone, another complex where there is no known levels of lead. However, the lead levels still are increasing despite their removal and put into housing that has no lead levels. So the question remained, how could they be still exposed? Well, it was pretty simple. They were getting it from the playgrounds and the places they played. And what we found out is that taking soil samples, there was very high lead levels. And in this ABC Primetime Live, they actually go through and look at the work that was done by Laidlaw and Filippi and Milkey and Reagan. And they actually collected soil samples along all the major interstate highways across the United States. And what they were finding is that there was very high lead levels everywhere, and it actually went several miles. So for instance, in Washington, D.C., you could have soil samples like we were talking about 1,200 parts per million, all the way to 7,300 parts per million in the soil in front of the house, such as Washington, D.C., where there's a lot of traffic. And this is sometimes lead levels you find in smelter areas, not even considering, near any kind of lead-based paint or demolishing. So these are extremely high lead levels, but it also says that not only the children exposed, but also the workers who are doing work in the area, gardening, all these things, people are exposed to. The children playing in the barren soil, above 1,200 parts per million, very easily to get to. So this video was very, very important to see. Again, it was an eye-opener for a lot of people when the leaded gasoline was being removed, that we have this legacy that we'll consider to be a problem for all these construction workers for a long time. Besides children playing in the backyard, there became substantial exposure to lead for workers performing construction work, as we said. This lead has been deposited in soil for years of using leaded compounds in gasoline. While leaded gasoline has been banned for road uses, soil samples can be dangerously high in lead, especially in urban areas where vehicular traffic has been historically heavy. This contaminated soil is referred to as aerial deposited lead soils. At certain road construction sites, hazardous levels of lead could be present in the air and could be also in the soil. Results may take it necessary for personnel to wear PPE and respirators, which could also in turn make requirements for medical surveillance if necessary, depending upon the worker's blood lead levels or an acceptable limit. As I said, Milky and Reagan and Laidlaw and Filippi did a lot of work with regard to taking soil samples across the roadways in Syracuse, New York, Indianapolis, and New Orleans, just for naming a few. Their findings confirm the increased risk of those who work on roads on highly populated area. The same correlation was found in high lead levels in relation to nearest roads, urban settings, and much even higher lead content than rural counterparts. In urban settings, the highest lead levels were above 900 parts per million and found in soil and samples within 10 meters of a road center. This 10-meter range was almost always include roadway shoulders. The shoulder is the area of the most exposure to roadway workers because there's so much access to road surface and is often area apart that is not disturbed by the road activities and equipment. Therefore, in this area, the roadway workers are getting the maximum exposure to lead. Although the soil samples of lead are generally stable and not disturbed, typical actions done by roadway workers crews will cause the lead to soil to become airborne and dust, and particulate in the forms that are hazardous to humans. Soil lead levels drop moving away from the road center, such as 40 meters away from road center, lead levels are below 500 parts per million soil. But again, workers are not necessarily exposed to this unless the soil is disturbed. Excavation, moisture of the soil, and weather conditions are factors in dust generation. Even at the lowest levels found by Laidlaw and Filippi, these lead levels were still above 100 parts per million in rural areas. The lowest urban levels are still at 400 parts per million in most cases. At these levels present in soil in the form of lead chemical residue, lead could be easily a risk to people who disturb the soils itself. A literature search shows studies assessing lead in the soil concentration of sources conducted in a wide variety of communities across the United States. Lead is present naturally in soil, with most regions at relatively low levels. The U.S. Geological Survey estimates that the concentration of naturally occurring lead in soil have a natural geometric mean of 16 parts per million. Soils containing more than 50 parts per million, but less than 200 parts per million are of concern. EPA standard for lead in bare soil in play areas, as indicated in the previous presentation, is 400 parts per million by weight and 1,200 parts per million in non-playing areas, according to EPA in 2000. This regulation applies to cleanup projects as well as using federal funds. The soil screening level, SSL, for lead represents a conservative estimate for a level that would be protective of public health in residential soils based on analysis of direct ingestion pathway for children. This value is a guidance only and is not enforcement. Soil screening guidance levels are only required for federally funded projects under 40 CFR Part 745 in 2001. Let's talk about what the TEL and TML look like. Well, basically they are colorless liquids, usually dyed red, orange, or blue with a pleasant sweet odor. The exposure routes are inhalation, skin absorption, ingestion, skin and eye contact. The symptoms of exposure can range from a variety of non-detect to very mild or significant intoxication, which causes insomnia, lassitude or weakness and exhaustion, anxiety, tremors, spasticity, bradycardia, hypotension, hypothermia, pallor, nausea, anorexia, confusion, hallucinations, psychosis, mania, convulsions, coma, and eye irritation. Physical symptoms are not prominent, but bradycardia, hypotension, and increased reflexes and tremors and weight loss are prevalent. Diagnosis of exposure to TEL and TML are dependent upon the onset of encephalopathy. Biochemical measurements are not helpful, but diagnostic levels of blood level are. Blood levels are not always elevated proportional to the degree of intoxication. Urine, aminolevulinic acid, and coproporphin levels in excretion show levels close to normal, while no correlation is related to the severity of intoxication. Erythrocyte porphyrin levels all remain normal. There are no cases of poisoning by skin absorption found in literature. Medical surveillance in both pre-placement and periodic examinations are required, but the workers' compensation or workers' health should be carefully evaluated with special attention to neurological and emotional disorders. As I said before, during the emissions burning, that there still will be TEL and TML in the soil. It'll be in smaller amounts. Biological monitoring is required for people who are working along roadways and other areas of construction. The interval between brief and prolonged exposure can be up to 8 days. The prognosis is guarded when the time interval is very short. In some circumstances, a brief fatal outcome may result. Recovered patients show no residual damage to nervous systems with exposure to lead alkyls, and the recovery period may be long. Organic lead levels such as TAL, TL are vapors, but they behave as gases in the respiratory tract. They're absorbed to a greater extent than the inorganic lead particles. Organic lead compounds are also absorbed through the intact skin, as I said before, both in humans and experimental animals. They relatively oxidize, and these organic compounds can be produced reactions the same way as measured for inorganic lead. In humans and rats exposed to alkyl lead, concentrations of lead are highest in the liver and kidneys, followed by the brain and heart. In human, tetraethyl lead is excreted in urine as diethyl lead, ethyl lead, and inorganic lead. In humans, exhalation of unmetabolized tetraethyl lead and tetramethyl lead can be found in the lung as a form of excretion. We talked about avgas. Well, avgas spirits with TEL reached the height after World War II, when they were looking for high octane levels for supercharged engines such as the Rolls-Royce Merlin and Gefron engines. In military aviation, TEL manipulation allowed a range of different fuels to be tailored to specific flight conditions. Aircraft operated on leaded gasoline, avgas, for many critical purposes, including business and personal travel, instructional flying, aerial surveys, agriculture, firefighting, law enforcement, medical emergencies, and express flight. Avgas is a special fuel used to power piston engine aircraft. Aviation gasoline complex mixture of hydrocarbons can vary widely in their physical and chemical properties. Properties of avgas may be properly balanced to give the reliable and safe engine performance over a wide range of aircraft operating conditions. In 1996, EPA promulgated regulations that banned the use of lead gas in highway fuels. But, as I said before, they allowed them to continue to use in avgas, race cars, agriculture, and other scenarios. There are about 20,000 airports, heliports, and similar facilities nationwide that use lead gasoline. EPA estimates about 14.6 billion gallons of lead avgas were consumed between 1970 and 2007, emitting nearly 34,000 tons of lead in the air. Leaded fuel is used roughly in 170,000 piston aircraft, estimated to be used nationwide. These are all your municipal airports and commercial aircraft, which operate over 13,000 airports. The small gasoline-powered generation aviation aircraft comprise the largest single source of lead emissions in the United States. While there's no safe levels of lead in the body, lead exposure is of special concern with young children. It puts them at a wide risk of health impacts, including lower IQ and behavioral disorders. Lead concentration there with proximity airports with piston aircraft expected to disperse this lead in the air over a wide range before it's deposited in soil, water, vegetation, and other surfaces. About 16 million people live within 1 kilometer of the 20,000 airport facilities in the United States, and more than 3 million children attend school within 1 kilometer of these 20,000 airports. Over 75% of the precision engine general aircraft run on unleaded automotive or MOE gas, which is ethanol free. These planes could be easily switched to unleaded fuel if they obtain the necessary permit and if unleaded gas is made available at more airports. However, 25% of the aircraft that do require high-octane lead fuel are the larger aircraft that fly longer distance and therefore consume the majority of bad gas. Several studies in the United States and Canada suggest that lead levels in air and soil near airports are significantly higher than lead levels in other distant airports areas. There are exponential decrease in lead levels with increasing distance from runways. Lead is used in raceways and race fuels. Just a little bit of lead gasoline can raise the octane level about 20 points. This is why you see many more unleaded racing fuels than octane ratings over 100. Another advantage is that lead doesn't have a significant effect on combustion properties like flame speed. This has allowed us to use certain hydrocarbons in a blend to achieve desired fuel properties. Racing gasoline and racing fuel cannot be used and discussed interchangeably in routine automobiles used by passenger cars. And in even racing, not even every type of racing uses the same type of fuel, as each series and sports has vastly different demands and requirements. Dozens of types of racing fuels exist, primarily used in formulas that include conventional gasoline, ethanol, methanol, and nitromethane and nitrous. Leaded fuel, which is used heavily in the past, can no longer be purchased, as I said, on use. In short, because the race cars use different types of styles of powertrains, those powertrains have different advantages and limitations to exploit the work within and the races that are being driven and the goals that our races are different. For today's gasoline engines, methyl tertiary butyl ethyl ether is now used as the anti-knock agent rather than unleaded gas. Thank you much for your time. I appreciate the opportunity to present this important subject.
Thank you so much, Mr. Fontaine, for your presentation and service today. So we'll open it up for questions for the attendees. Again, if you have any questions, please enter those into the Q&A box, and Bill Young will moderate those. And then for the panelists, you can feel free to just unmute and ask.
So Bernard, I guess you've kind of shown along roads and everything and leaded highways and stuff, and I guess I was seeing some things where there's concerns about lead being uptaken into fruits and vegetables and food that we eat, you know, and a lot of the products that we get that are made with food and stuff like that, canned goods and things like that. Did you get or see any studies of that kind of issue where it would be more away from highways and where cars typically go, but on farms or in other countries?
Well, the major concern, even in developing countries, is the fact that the fruits and vegetables that are sowed along the side roads can be contaminated with the leaded gas. And that's the reason why they were pushing so hard to get rid of it worldwide. But even when you look in the United States, unless you were having a garden in your backyard, then you were basically in soil that would probably be higher lead levels than in a rural setting where you actually have a farming community. Even the farmers using the leaded gas is not a significant source of emissions. But anything in the nearby urban rural that would be a very concern. And that's why soil samples become so important.
Great. So, Mr. Fontaine, thank you again so much for your service and your presentation today. We appreciate you being here with us. We'll go ahead and get started. And thanks, Bill, for being my co-moderator today and for all your work and producing this agenda for the day. For those of you that don't know Bill, William Young, he is with WM Young LLC, and Bill's experience comes from 25 years at Dow Chemical, over 10 years at NASA JSC, and 26 years as an adjunct professor at UH Clear Lake. And Bill's background is he started as a research technician, was a foreman, and then moved into industrial hygiene and safety, to say the least. So Bill, thanks again for all that you've done today, and I'm going to pass it over to you.
All right. Well, thank you for suffering today. You're probably wondering what on earth did I do to deserve all of this? So anyhow, I thought I would kind of give you some background. And now, since I'm the closer, I'm kind of going to give you some of the basis for why we got into this pickle today. But I thought, you know, it would be something different than COVID. And so hopefully, I know what y'all are thinking right now at this point, that you wanted to know how much a blood lead level test is going to cost you if you go to Quest Diagnostics or something like that. And so the reality is I think it's around $60. I have not done it though. After watching all of these presentations and actually preparing for all this, I actually started thinking about going and getting a blood lead test and everything. So anyhow, I'll kind of give you a little background, and we're not going to go quite into the testing as much as I had hoped to, but the XRF machine we didn't really get in touch with or a hold of one, so we're going to kind of spin off in a little bit different direction. I hope you saw on the agenda that you had a homework assignment, and I'm sure everybody's prepared that by watching the 45-minute video and looking at the report that was attached and stuff like that. But so we're going to talk about some sources of lead exposure concern other than lead-based paint. I thought Freddie went through a really good, and we've actually had a lot of the speakers talk about lead-based paint and lead and, you know, other areas of exposure. And that's kind of what started this thing, was that I was actually taking a course of Freddie's on being a lead inspector and a lead risk assessor and stuff. And I got to thinking about it, and then the more I looked into it, the more curious I became, and then I found out, yeah, there's a lot of things that I didn't realize that were happening. So we're going to look at some of the new sources of lead contaminants and old sources. We're going to talk some about sampling and how do you obtain samples for analysis and everything like that. I guess also really trying to describe some of the results of sampling for items commonly found in homes. So I actually went around and got some samples and took them to a lab, and they were kind enough just to run them and everything. And it was kind of interesting, some of the things that I learned from that. So if you think about things in your house that you would like to have tested for lead, that's something that you may want to consider. So how do we get lead in our body? Today we learned there's a lot of different ways, right? And so elevated blood lead levels, we can also get it from food and spices, and that's kind of the direction that I'm going to go with this little part. And we saw before a lot of different presentations include paints and coatings. I remember we had a lead session many years ago. I think it was about 2002. The Greater Houston Industrial Hygiene Council had one in June, and I remember that some of the elevated blood lead levels of little children were found to be, you know, even in upscale houses in the Conroe area. There were very nice houses and stuff like that, and there was a young child that ended up with elevated blood lead, and they tried to figure out where this kid was getting this elevated blood lead level, and it turned out to be antique furniture that they had an old chest that was varnished and wooden and everything, and the varnish ended up being full of lead, and the kid liked licking on the varnish and stuff. So so it was always kind of unique. And Freddie didn't, in his class that he talked about, he even talked about a kid that was chewing on a key fob that mom was kind of giving him to shut him up and stuff, and that ended up leading to elevated blood lead level because the fob for the keys, the rubbery chewable plastic little kind of item, ended up having high blood lead. So there's lots of ways that this happens, and apparently it's still going on, and that's what we're going to talk about. But so there's a lot of things that are chewable, and we've seen a lot of different examples of things that can have lead in them, including, blinds for windows and things like that. So anything a kid can put in their mouth. And I've got two young grandbabies, a 1-year-old and a 2-year-old, and the 1-year-old, will put anything in the mouth at any moment. So you have to keep an eye on them and stuff. And then we also get lead because of air pollution. We live near Hobby Airport down here. And so there's planes flying overhead all the time, and planes in the air. And so there's lead that's being sent out, and there's pollution levels of lead that's just associated with being in a big city and stuff. And so there's assumed quite a bit of lead in the ground and stuff. And that lead tends to work its way into the water table, and so there can be water contamination from lead, which is another concern. All of these are ways of getting lead into your body, and in an adult, it's not nearly as bad as it is for a very young child or children. And so, and we heard earlier, and I think I'm going to go through the same kind of stuff. The Egyptians, makeup and eyeliners, and that was another thing that was expressed when I first brought those samples to the lab, that they mentioned there was a spice shop in League City that I needed to go visit, and they weren't sure if they were only selling spices or what else, but that there was some concerns about things that were being sold, and a lot of it was imported stuff, and I think stuff that was being made in other countries. And so it seemed like, wow, there's a lot of places where you could end up running into lead, amounts of lead that you may not anticipate. And then of course we all have our little hobbies, as you heard earlier about the guns, shooting range in your garage and things like that. And I know some people do muzzle loading kind of deals. And so there's, and making sinkers or fishing weights and things like that are all additional ways to end up getting lead somewhere around on the surface that you may end up, either getting ingested or put into a place where some young child could end up getting it into their system and stuff. And then the other one was really surface contamination. So if there's dust or accumulations of stuff or carpeting or things like we heard about earlier, that there's a lot of different things that folks can end up getting into. But so yeah, I had an alarm. That was what was going on. But the time schedule got changed a little bit. So anyhow, so there's a lot of different ways that we can end up getting lead in, and this topic kind of piqued my interest again, because as I read more into it, I kind of learned a few more things. And so I was attending the lead inspector and risk assessor classes, which are approved by the state of Texas. And in that class, I met a lady that was one of the Harris County lead or lead control persons. And she was concerned because her daughter was making a lot of foods and using a lot of unusual spices that she wasn't too sure about. And she was really concerned that some of these spices may end up having lead in them. And with her daughter having young children and stuff like that, she was kind of concerned of that as a lead control person. And they're pretty restricted on having to follow HUD guidelines and only, do what's authorized and under the regulations for HUD. So she can't really go out unless there's some kind of a risk assessment that's being done. Can't really go off-road and do testing of other things and stuff. And so, and I started looking around to try to figure out, well, I wouldn't have thought food spices were really that much of an issue and stuff. And then I was talking to my son, and a couple of months ago, they stopped feeding these two young babies baby cereal, and due to reported elevated contaminations of lead, arsenic, and cadmium. And so I found a CNN article online and stuff about these heavy metals that were being found in baby cereal and baby foods and stuff like that. And the CNN, and it was actually a meeting at Congress where they were having a review about lead levels in children or baby foods and stuff like that. And it was like, but when I went there, what was really kind of different about it is that they were concerned in calling toxic levels for infants and everything down in the parts per billion range, not the parts per million range. And so I was like, wow, that's like 500 parts per billion and stuff like that. And 100 parts per billion is toxic amount of lead. And I was like, holy. So a lot of this, and you heard Freddie say earlier, and that was the other thing I kind of ran across, was the FDA has been dropping the numbers. And basically they're saying, yeah, we need to get lead out of the picture, remove lead hazards from our lives as much as possible, because it does affect really young kids, and it can cause a lot of effects that are not really good. And so that kind of kept me kind of wandering through this and everything. And again, I actually found some stuff, and I'll share here in a little bit, but makeup, women's makeup has had lead in it for quite some time. And there's lipsticks and eyeliners and all kinds of stuff that it used to be, it was pretty well known, because since Cleopatra, it's been, normal to have lead in it. And so there's been a push, I'm sure, in the last 20 or 30 years or something like that, to reduce the amount of lead in makeup and skin products. And there are still those products that come in from overseas that may contain higher levels and stuff. But the FDA was actually pretty involved way back in 2007 and 2010, and I got a little excerpt out of that. But so the more you look, the more you find, and the more things that you're kind of raising a little bit of curiosity about and stuff like that. And so that Harris County lead control person was really saying, hey, there's still elevated blood lead levels in Galveston and Harris County, and that's still an issue. And you can go to the web and look up, and they have tables out there by county on blood lead testing and elevated blood levels. And this is 2019, which was the latest year I found, but there's a bunch of years before that on how many children are tested in the county, 0 to 5 years old, and how many of them end up with elevated blood lead levels. And as you can see in front of you, there were 72,000 kids tested in Harris County and 3,000 kids tested in Galveston County, and out of that, 646. So that's a little less than 1 out of every 100 kids are being, ended up with elevated blood. But that's 1 in 100 kids. Those are not very good odds. That's from a safety perspective. And look at Galveston, it's almost, it's over 2.5% basically of kids, 82 kids out of 3,000 that ended up with elevated blood lead levels. And so each of these becomes a case, and somebody's trying to track down and figure out, well, where is this kid getting this elevated blood? And a lot of those stories are what you heard today. There's remedies, and there's pottery, there's all kinds of places where kids are getting this lead. And so the big idea would be is we need to really try to see if we can minimize and try to reduce that and stuff. And so there's actually three tables there on the Texas webpage, Texas Health and Human Services. And so for 2019, the other table that I don't show is it has a 1 and 2 year old breakout for number of children tested and elevated EBLLs and stuff like that. But you can see in older kids also, there were still quite a few that were tested, and in Harris County, there ended up being over 1 in 100 that ended up with having an elevated blood lead level, even though they were over 6 years old, somewhere, between 6 and 14. So again, yeah, it sounds like, and there's actually a Galveston lead control group and everything, and they have a lab in Lamarck that runs blood lead levels and does lead testing and analysis, and I think they do blood lead levels. I know they do testing and analysis and stuff. And I actually tried talking to some of them about coming and talking today about some of the things that were going on in the county and stuff like that. But as you can kind of see, that it's still an issue. And then I ran across this article that was actually a posted report that's at the CDC, the Centers of Disease Control webpage, where there's a whole article, Lead in Spices, Herbal Remedies, and Ceremonial Powders Sampled from Home Investigations for Children with Elevated Blood Lead Levels. And this was in North Carolina from 2011 to 2018. And I really wanted to get this lady, Dr. Kim Gates, to come and speak to this group on this session and everything. And she has a video out, and that's part of your homework assignment, was to look over this report and everything. And also she has a 45-minute video that you can watch that was really, really interesting about lead being in food. And that's kind of what she's put together, a big study and gathered a lot of data. And this is some of the stuff that was done. So it looked like they did tons and tons of analysis. So basically, I apparently didn't shut off my alarm very well. So anyhow, just looking down this, it's kind of broken up into 3 different groups. Her tables were non-food items, which this is a different thing. And so it's the number of samples that she did. So cum powder made from turmeric and other materials, she had 12 samples of those. And the range is over there in that right column. It's 0.4 to 140,000 milligrams per kilogram. So not to be confusing, but milligrams per kilogram is the same thing as parts per million or micrograms per gram, or so it's all the same kind of stuff. And then she goes through and says what the average is for those, which was 12,185. And then the standard deviation goes up to 40,276. So she did a bunch of different samples, and for things that she only had one sample, that you can see there's no range and it's not applicable, and there's no standard deviation if there's one sample. And the Sumra at the, or ground into powder used as an eye cosmetic had 68,000 milligrams per kilogram, or 68,000 parts per million. So it started to become pretty clear that, hey, there's some stuff out there that you can get in the, probably available for the public or for people that can end up giving you a pretty good dose of lead, even if you don't have lead as an issue in the place that you live. And so I looked down this list and I saw chili powder, and we do a lot of chili powder and red pepper on pizzas and stuff like that, maybe even, a day or 2 ago. So she had done 23 samples of chili powder, and you can see they ranged from 0.1 to 170. And so they didn't really give what brands or any of that kind of stuff. But they did have an average of 12.6 parts per million lead in the chili powder. So that was a pretty good dose. And in her report, she's really saying, look, it needs to be below 1 part per million for children, or for young kids and babies and things like that, you know, feeding them higher levels on any kind of regular basis could end up creating health hazards and issues. And indeed, that was part of the whole thing on the report on trying to reduce it in baby cereals and stuff. A lot of times when that stuff gets taken in, it bioaccumulates, and there's a certain amount that, as we heard, it may take a long, long time for that to get out of their bones and out of their teeth and things like that. And so, and it ends up causing all these problems, and you have nerve problems and things like that. So cumin was on this list, and it wasn't nearly as high, but you can see it was still above the 1.1. But so she tested a bunch of different ones, and turmeric there at the bottom, there were 34 different tests, and the high was 740 parts per million. So it wouldn't take very much of that spice on your food to probably give you a pretty good bit of lead and stuff. And so they also did vanilla. Who's familiar with that? So there was a lot of different things that would under food items that now we kind of are wondering about whether there may be some issues and stuff like that. And that kind of continued to drive me. And then there was another table that had medications, oils, and supplements of this study. And as you can see, like the saffron supplement is used, it had really high numbers, 2,764. And so then down below, other food products, well, look at there. There's a baby cereal, and 2 baby cereals were tested, and they were ranged from 1.2 and a 34 was the other baby cereal, 34 parts per million lead, and the average was 17.6, which is half, and statistically it could have been as high as 23.2 parts per million. And so baby cereal, cornstarch, and that's kind of what the reason that I was asking about, are things out there, you know, on the ground, are they being taken up into food or something like that? But it seems like, yeah, if there's baby food, where is it being made? And I'm sure it kind of depends on where it comes from, or, you know, what part of the country it's being grown in, and, you know, what are the conditions. And indeed, I think there's some concerns with things that are grown overseas, although it seems like that a lot of what they're saying is the manufacturers should analyze for the amount of lead in their food or their spices or whatever, and that there's ways of eliminating and reducing the amount of lead contamination that's in something. So just the highlight of finding out, hey, you know, there's leads in lots of things, and there's lots of ways to get lead in here. And now, you know, it seems like in the new thing is really to reduce, to identify those locations which have lead, and then try to eliminate them would be one of the key things. So we're going to talk about sources of lead exposure concern other than lead-based paint. So here's our Egyptian eyeliner and Cleopatra. And as y'all saw earlier, there's a lot of different things that can still contain lead, including lipsticks and stuff. And so, and I read one thing that said, yeah, they were trying to keep it down below 50 parts per million lead in lipsticks. And so I was like, well, yeah, kissing babies with that lipstick's probably not going to be real good for babies and stuff, or licking your lips and things like that. And so that was one of the FDA's kind of articles about that. And then, as we saw in that list, the medicines and cures were a problem, foods and spices. And then this was kind of the assumption was plant-based food in regions that are still using leaded gasoline, the uptake into the foods, even though it may be containing some lead. And so the real issue is that the concern is that lead gets into very young, babies and infants and things like that. And it may get into the mother who's also passing on milk, and so you can end up having this lead being transferred and accumulating in unacceptable amounts in babies from a bunch of different methods, a bunch of different ways. And so the other one was pottery and glazes was another possibility. And we saw there was sometimes they use ceremonial dishes and things like that. And that's been pretty well known and everything. And so I thought I would go out and catch some samples and just see what stuff ran and everything. And so we're really kind of looking at it. And I did hear earlier today, so yeah, in the blood, it doesn't, it has a biological half-life of 1 to 2 months. So it's not going to get out of your blood very quickly. And as you heard earlier today, that it can end up in your soft tissues and years to decades to get out of your bones and stuff. And those years to decades with a toxic level are going to create a lot of effects or health effects and things like that. So that's really what we want to try to reduce. And as we saw, if we have lead in paint, especially red lead primer and things like that, there's a lot of issues that we need to manage it really well and make sure that we're not taking it home or taking contaminated stuff home. And as I mentioned, even clear shellac or varnish, it's not always, brightly colored paint or brightly, or things like that. It can be in clear stuff, can end up having lead and everything. And then we talked earlier, we heard about plastic toys that kids can eat, especially, the ones that have paints on them and things like that. So there's a lot of things, and we have the consumer safety protection folks that are looking over and trying to make sure that we don't end up ingesting lead or having sources around kids that could end up being more affected by that and stuff. And then we've kind of hit these other ones as you saw earlier. And so I didn't get a chance to get an XRF, although we talked about it quite a bit in the class. And the folks from Harris County and Galveston County, they both use XRFs because they're primarily, like I said, they work on HUD stuff where they can go and use the radioactive source to analyze for lead and everything. And so I ended up catching samples and putting them in. I called the lab and they said, just put them in a small Ziploc bag and give about a quarter size worth of dust. So in thickness and everything. And also in the class, I learned you don't want to cross-contaminate your samples, which makes a lot of sense. And then they use this ICP, inductively coupled plasma, to do the analysis of samples. And so the ICP for this lab was pretty much the main way that they do things. And I know there's a lot of really fine print. Gonna have to get close on your computer screen to see, but so they have reporting limits, and so the limits, and then to the right is ICPs, and you can see the labs uses this ICP machine for doing everything. Now the bad news is I wasn't really paying very close attention. So, and the lab actually found another procedure, which we'll talk about in a little bit, that's for testing for lead in food. But these are those things that you heard Jan talk about earlier, where the NIOSH 7303 modified for bulk material or for sand or for paint, or soil or paint or wipe samples. And so they use this same kind of machine in order to analyze, but the levels of analysis are typically pretty high relatively to parts per million and stuff. So you can see in paint, it'll do, the reporting limit is 50 parts per million, and where it talks about in percent. So it doesn't really have, there's a ICP mass spec that really can get down to that 1 part per million, which is what a lot of the food stuff was being analyzed to. So I didn't really ask or try to find a place that had that kind of a instrument and everything. So I captured some samples just trying to see, okay, well, what kind of stuff do you get on? And the lab, actually, they referred and said they found that procedure for testing for food, but they followed that procedure using the weight because they basically weighed out that and everything. And so they ended up following that procedure pretty closely. But the results, again, when you got below 50 parts per million, they said, here, we'll report it to you, but that's really none detected with the method that we were using. And if you remember the plant stuff and a lot of, the outside areas where they were saying several thousand parts per million or micrograms per gram, that kind of level. So those were really, really pretty high at the time. So object of the game would be to not take that kind of stuff home. So I went around our house and I picked up 8 items commonly found in homes. I'm assuming somebody has a piece of Mexican pottery, something made in China, some spices in the kitchen area, in the cabinetry and stuff like that. So here we go. I went out and I found some baby cereal, actually, because that one kind of tweaked my interest on whether, hey, baby cereal may be an issue or not. And so in that video, Dr. Gate talks about, that anything that's kind of brightly colored in food, sometimes that coloration is may have something to do with lead. And so I kind of heard a mention of mac and cheese, the powder. So I thought, well, I'll test some of that. I'm not real sure, but that would be really a terrible thing because we fed our children a ton of mac and cheese powder when they were growing up and they were little babies and stuff like that. So we found some cumin and some chili powder spice in the cabinet. In fact, it was pretty fresh. And I took pictures of their expiration dates. And then we had some curry powder. And I went and talked to my wife and got some lipstick from her, which was pretty old, but we were going to see if it could be tested. And the lab said, well, it does have some organics in it, and we're not too sure what the results are going to be like. So, but we'll try to test it and all this kind of stuff. So, and I didn't realize if you Google lead in lipstick, there's a lot of information out there. So we also had a piece of Mexican pottery that we've had probably over 40 years. So I figured, well, that would probably be something that may contain some lead. And we have a candle holder probably bought from Pier 1 or some place that was made in China pretty obviously. And I thought, well, we'll just scrape. And so the sides was painted gold, but the bottom was painted black. And I just decided, well, I'll take some off the bottom and have it tested. So I have a caveat. So I only took one sample and only asked for one sample to be analyzed, which we don't do very frequently. We don't make decisions. Hopefully we're not trying to compare to OSHA things all the time. If we go out and on a similar exposure group or HEG, we're going to not make a decision based on one sample. Although when I was working at Dow and we went on customer visits frequently, that's all we had was one day. We went in on one day, we did training, we did sampling and air monitoring for isocyanates or something like that. And so realistically, I've taken one of these samples and it may not be really representative. I could have probably put in 2 or 3 samples from each of the things that were being tested, and that would technically be better. And then even if there's a product like a spice or something like that, it would have been good to get more than one jar of that spice and then test more than one sample just to see what kind of repeatability. So this has no repeatability. I mean, it's just saying, yeah, okay, I went and sampled it, and you know, I had it analyzed, and here come the results. So, and my wife and I had a pretty big discussion about what I should show and not show, and she was very worried that I'm going to show some products from some manufacturers, and they're going to not be very happy, and so I ended up redacting a whole bunch of stuff. And again, so if you look, there's a method, and I'll show you here in a moment, but there's ICP with mass spectrometry that can really get you down into that 1 part per million accuracy range. Whereas this one had a 50 parts per million, was considered none detected, and that there were some stuff was showing up below that. In fact, all the samples that you just saw, including the baby cereal, all of them had some lead in them, which is what the lab told me. Hey, it was not 0, it was some number, and we can't fairly say specifically how far below 50 parts per million, but they did give us some numbers, and I'm going to share those with you here in a moment. And so, and this analysis that was used was an AIHA 7303 modified method, which is kind of the one that's pretty standard. And as you saw on the list of analytical methods, that's one that's used for paint chips for lead contaminated soil. And so the limit of quantification is like 50,000 micrograms per sample, or 0.05% or something like that. So anyhow, abracadabra, here's my heavily redacted products. So this was chili powder. And so how many guess that chili powder is going to be? So anyhow, so this is the 2.5 ounce container. And so realistically, the results were less than 50 micrograms per gram, which for you hygienies, that's the same thing as a milligram per kilogram, or parts per million. That all's the same thing. And this is weight by weight instead of by air volume, right? So they also reported, the lab reported a lead raw result. And for chili powder, the lead raw result I would still have to report none detected because of the method, but they said, yeah, it seemed like there was more than 1 part per million lead. In fact, there was probably like around 6 parts per million lead in chili powder, which I wasn't really too worried about that up until my son, and, going and following up on what baby food manufacturers have goals to have numbers below 1 part per million. And so their goals are like 1/2 or 1/10, 1 part per billion or stuff like that. And so like I said, I also did powder and spice Indian curry powder. And so there's my standardized Ziploc bag, properly labeled, I think, for curry powder, and it ended up having a little bit more, 16 parts per million roughly of lead came out, even though that's probably not an accurate amount. But again, it was not 0. So for those of you who are thinking, hey, we want to make sure we're not putting any really bad levels of lead into our kids, we need to probably watch the spices that we're cooking with, because as it turns out, all of these things ended up having some lead associated with them and stuff. And so this is ground cumin, which was also on the hit list from Dr. Gates, and it again was around 6 parts per million roughly from the method that was used with the ICP and not the ICP-MS. So, and this is pretty fresh stuff. This wasn't too old and everything. So, okay, here we've gotten to our Mexican pottery. So this is technically, I think, a water jug and a glass, and the glass fits up on top of the water jug and everything. And so on the left picture there, you can see the bottom is where I ground about a quarter size hole in depth, also in taking the glaze mostly, and then some of the pottery part also. And this thing was pretty old, and we've had it around forever. And we ended up being, and this was the only thing that actually tested out to be over the 50 parts per million detectable limit. It had 1,440 milligrams per kilogram, or micrograms per gram, which is all different ways of saying parts per million. So yeah, it ended up being the only thing that really had something. And I don't know if it was in the glaze only, because I didn't try taking out a quarter's worth of the glaze when I was trying to remove that with a Dremel and stuff, or I don't know exactly. It was part of the pottery part along with whatever was on the surface and stuff like that. So this was our Chinese candle holder, and it was made in China. And so I went ahead and just ground apart. And as you can see, it's kind of got this goldish paint on the sides, and there probably was not gold paint on the bottom, but I ground a hole in the bottom of it and everything, again, about a quarter size, and it ended up being 30 roughly. So there was quite a bit more. It was still below 50, so it's still non-detected, but seems like it still had more lead than no lead and stuff. And again, so this would be something you don't want to have a kid chewing on or have in places where the kids can get it on their hands and things like that, or end up getting their hands in their mouth or things like that. So okay, so then we went to mac and cheese powder, survey says. So so we went and got one of these things, and they all have a cool little packet, and we used to do the boxes all the time and everything. And so we sent off some of this for the lab for testing, and you can see that's not zero. So there's some in there. And again, I think if I was going to do this again, I would probably go back and have it done with the ICP mass spec and get a little more closer number and probably more testing. And probably if I Googled this and went out online, I could probably find the answers to all these questions because I'm sure some folks are doing testing and stuff like that. And a lot of the manufacturers, the things that I've found, and even the ones that were cited in the CNN article, they're testing and they're looking at heavy metals and stuff. They're looking at arsenic, especially, was one of the things that was written up a bunch, and everything, that they're really trying to make sure that they're not passing on dangerous foods and things like that. So my hope would be that none of this, it would all have none detected and we wouldn't have any kinds of issues, but that's not kind of the way it plays out. So indeed, there's a possibility that we're getting some lead from a variety of different sources that we may not be aware of, and that's the whole purpose of this presentation. Okay, ladies, I had to really do some heavy redacting here on this lipstick. And so this lipstick was over 10 years old. I'm sure they had some difficulty trying to burn it up in that plasma incinerator and everything. And so do you think it was less than 10 micrograms per gram or 10 parts per million? And the answer for this is really no. It ended up being a little bit higher, not quite as high as the China made in China candle holder, and not for sure as high as the Mexican pottery. But so the big question is, kissing babies with lipstick, do you know how much lead may be in the lipstick that you have, or grandma has, or something like that? And so this is, by the way, so there's an FDA study that was out, and I think in 2007 they did some months, October through December, and then this was another expanded survey that was done, and in the fine print there it says they did lead content and 400 lipsticks were obtained by Frontier Global scientists under a contract with U.S. Food and Drug Administration. The lipsticks were purchased from retail stores between February and July 2010. So that's about the vintage of the stuff we had. And here it's Maybelline. And I think this was at the top of the table, which was all listed kind of by the most lead and to the least lead. Well, they said, yeah, it has 7.19 lead part per million in this study of 400 lipsticks that was done and posted on the FDA webpage. So, okay, so maybe there was some lead in the lipsticks and stuff. And so in that same area, in that same article, the FDA said, hey, we think 10 parts per million lead from incidental ingestion of cosmetic lip products is very small and cannot be measured in routine blood testing. Based on these factors, we concluded that up to 10 parts per million lead in cosmetic lip products and externally applied cosmetics would not pose a health risk. FDA regulations usually limit lead as an impurity in color additives to no more. So it's an interesting, they're trying to keep it down around 10 or 20 parts per million. Like I said, I saw another thing that was earlier saying, hey, yeah, we're going to keep it below 50, and now it's, hey, we really want to keep it below 10. This is for the adults that's licking their lips, not necessarily kissing babies all day long. But I guess the thing is going to be, yeah, with the numbers moving down on babies and stuff like that, we're really, the object of the game is, yeah, we need to identify those things and continue to move. That most of that 400 list was really low numbers. So like I said, this Maybelline product was the highest thing on that list. It was the top of the 400, and it was by the amount of lead that was in it and down. And so, that was still below 10. So they were happy in 2010 and stuff. So just as another tidbit. And here we go, baby cereal in my somewhat redacted picture. And so we tested for that one, and again, it didn't test zero. And this, or I'm not so sure, maybe the mass spec methodology would have been better off, but you can see, and kind of what I was told was, hey, it's not zero, there's lead in that baby food. So again, in those articles, this is another, by the way, CNN's report, they were really focused on parts per billion levels in baby food reported in a congressional investigation. And they were using sentences like dangerous levels of toxic metals like arsenic, lead, cadmium, mercury exist in baby food levels that exceed what experts and governing bodies say are permissible. And so then goes on, and it says it's shocking because it shows evidence, and so contains hundreds of parts per billion of dangerous metals. And so that's a step down from what we in the occupational world, and that's what I think Freddie was trying to allude. OSHA, we know lead's not good to get it in your body, so we need to start looking around at all the different ways that you can get that. And if you live in a big city like Houston, then yeah, it could end up being an issue. So they did have some of the baby foods tested as high as 641 parts per billion lead when this was done. And this was a few months ago in CNN, and the reason my son and daughter-in-law decided, hey, we're not feeding those babies any more baby food, cereals, no more cereals and stuff. And I didn't click to, well, that may be okay. They read articles saying there may be, some correlation between that and exposures to lead and some other things. So again, we used chain of custody. Here's that procedure that the lab found. It's AOAC 215-.01, heavy metals and foods, and it uses the ICP mass spec, and they used a 2-gram sample, which is what AIH ended up using for these, and it probably would have resulted in a lower detection limit. So all of them had, all of them except one of the samples, the Mexican pottery, ended up being above that 50 parts per million detection level. The other samples submitted had so they, the analysts basically said, hey, there was lead in those samples. It wasn't zero, because that ICP would have said if it was nothing. And so, and then again, we knew the old Mexican pottery, if you have any of that, yeah, don't let your baby around that very well. And especially don't put alcohol in it or other things and things like that. So I think I've burned up more than my time. And actually, so I've got a list of the references that are in this slide presentation, including some of the articles. And Texas has an excellent lead control program going. It's been going on for a long time, but it's still a problem. So we need to keep working on that. All right. I think I survived that.
Thank you, Bill.
Still alive.
So you do have a question in the Q&A box, and for anyone else that has questions for attendees, please feel free to enter more questions into the Q&A. We still have a few minutes for questions before 3 o'clock. So we don't. Okay. Well, one is, do XRF radiation producing machines without sealed sources work for testing as well?
Without sealed sources?
That's what it says. And
So,
that was from Osman Aruz.
So I know there's a concern of radiation exposure when using an XRF, because it does shoot radioactive, radiation, radioactive waves or whatever out. And so I'm not sure. The XRF machine also, from what I understood in Freddie's class, only works on flat surfaces. You can't put it on anything that's round, and it won't test unless it's hard against a flat surface. But the problem is that you can put it on a flat surface and shoot through the flat surface. The radiation will penetrate the surface and go to the other side to some extent. So if it's not really a good barrier, then you could have radiation on the other side of that barrier, because it does have a radioactive source. I don't know if there's different kinds of XRFs that with sealed sources or without, but I know the ones that Freddie was talking about, they all have to be calibrated. You have to read that sheet and understand what the conversion factors are for the numbers that you're reading, depending on the type of surface that you're trying to take a reading of, and then also that it does produce radiation out there, so you don't want to ever have it against something solid and have something behind there that may be affected by the radioactive radiation. Does that answer your question?
I am going to say sure. Let's see. There was a comment from the person that asked that question that said, we have XRF radiation producing machines that do not use sealed sources. So, Osman, hopefully that answered your question. I don't know, or do you know of any resources, Bill, on the web on that?
No. Well, Dave Thomas, who we had his name on there, he actually sells a lot of different monitoring equipment and things like that. And originally he was saying he probably could get a hold of an XRF. So I'll bet you if he, with REPS, REPSS, he would be somebody to talk to that could probably give you kind of a, different flavor for the variety of things that are available and what may be considered safer these days. I know there's a lot of improvements in things where they're trying to reduce risk and everything. The Harris County folks, they were pretty aware of how to use that. And if you go to the lead control webpage for Harris County, they have pictures and a little video about, how they go out and test houses and different surfaces and stuff. So
Okay.
available.
Well, we got some positive feedback on these comments, so thank you for that.
Good.
This is good. So Scott Kaler in the chat said XRF uses sealed sources or X-ray tube. Sealed source always emits radiation tube. Sealed sources always emits radiation. Tube
Right.
only emits when energized.
Yep.
Okay. All right. Okay, well, this has been great. So again, thank you, Bill, for your presentation and for co-moderating with me and for your agenda production and just helping get all of this together. This has been great. So I'm going to close out for the day. As always, I want to thank all of our presenters and agenda producers and attendees.
Did really well.
This has been a great session. We've had a small group today, but I think, with the presentations that we had, this is still a good group. This will be recorded. We'll get that up and out to you sometime next week, early next week. And we'll also place it on our YouTube channel. So we'll have follow-up for this. If anyone would like to co-produce an agenda with me or with our AIHA Gulf Coast section here that helps out with this agenda production, please feel free to email me. You'll have my email when we send the follow-up. Or if there's any emerging issues or just topics that you're interested in, shoot me an email at any time, because that kind of helps us, gather information for any upcoming seminars that we'll have. There's plenty to talk of on that. We just wanted to give you guys a break from that, and I think we did that well today. So not that it's not an important topic, but this has been a great session. So again, thank you to all of our agenda producers, speakers, and presenters. And we are definitely going to follow up with you with an evaluation. Please, please, please complete that evaluation, because that is going to link later on to your certificates of attendance and CEUs for today. So please make sure you complete those evaluations. We'll get those out either tomorrow or Monday and get your CE certificates out early next week.